This is Qt 5 Design Pattern Section 4. We're going to talk about memory, and we often overlook this, especially when we're way beyond the advanced part of C++ and we're just in our zone and we're coding. So we're going to dial it back. We're going to talk about the stack, the heap, memory leaks and stale pointers, along with how Qt does memory management, including the parent-child relationships, RAII, and smart pointers. In this video, we're going to talk about something relatively safe, memory, but we're going to talk about the stack specifically. So this section is going to deal with memory management, something that we typically take for granted, but in C++ and especially Qt, we have to worry about. So the QObject class is pretty simple, pretty easy to understand. If you're taking this course, you're probably rolling your eyes and going, why are we even talking about QObject? Well, it's because QObject is the building block of pretty much everything in Qt, and because of that, it has its own little gotchas. Namely, you cannot copy a QObject. I'm going to say that one more time. You cannot copy a QObject. You can clone a QObject and you make a pointer to a QObject, but you cannot copy a QObject. And, well, that's because of this little guy here, the QDisableCopy. This thing will frustrate you to no end, especially when you're just starting off on Qt, or if you're trying to review somebody else's code and they don't understand this. This little guy will basically remove the copy constructor or disables them from any QObject. So if you try to copy it, it's going to throw an error. And there are a bunch of lengthy, reasons why. This guy right here, Alex, he has one of the best descriptions out there. So I'm actually going to put a link right in my description. But it really dives into why. And I can summarize this whole thing for you that Qt's design philosophy is that each QObject is an independent, unique object and therefore should not be copied, because if you copy that, you're now copying all the signals and slots and all the interconnections that Qt uses under the hood to track what that object is. So if you now take that object and make an exact copy of it, but then delete the copy, how is your application supposed to function? It gets a little confusing. So let's dive in here, take a look. And I'm just going to copy my notes here. Lots and lots of notes. Notes probably going to be bigger than the actual program. But really, what is the stack? Well, it's a chunk of memory that when your application is created, the operating system says, I bestow upon thee this memory. And you can find that in most operating systems. I think most Linux, Unix, Mac, Windows, you may need something different. Using the ulimit, and you can find through S and A what they actually are. So if I go, there is my stack limit right there. And there is some advanced information. You can see we've got a whole lot of little stuff here, but basically you get your max memory size, max memory locked, things like that. This all really controls how much your application can use, and by default this is limited. So if you make a program that just puts trillions and trillions of objects on the stack, eventually it's going to crash and die. And that's why we have pointers to begin with. You have pointers, the heap, which is also called the free store, because you have basically an unlimited amount of memory at your fingertips. It's really not true. Some operating systems do actually try their best to limit, and some randomize it and do crazy things in the background. But when you think of the stack, think limited. You're talking literally like a stack of papers on your desk. You're only going to be able to fit so many on there. So now that we've talked about that, let's make a basic object and just play around with this. So we're going to make this, call it my class. It's not going to be any scientific discoveries here. This is going to be very simple. I just want something to show the full life cycle of an object. And let's go ahead and put deconstructor in here. And we're just going to say created. And this will be the point of contention with some programmers where I'm going to actually say this is destroyed. And they're going to go, whoa, 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 you haven't actually destroyed it yet. It's in the process of deconstructing it. It's not actually destroyed until it gets here. You're absolutely right, but I'm not going to argue about it. It's just we're going to say I want to know when it's created and I want to know when it's destroyed. By the time you see this on the screen, it's already gone. So let's play around with this just a little bit here. So what we want to do is say, my class create. Yes, we're going to actually create a class here. And instantly it's going to say unknown type. So, all right, let's figure that out. And, oh, looks like we can actually do something here. So we're going to say my class and my class boy, I'm screwing that all up. Set object name. That's what I'm looking for here. And we're just going to return this. Instantly we have a problem. What is this? Call to implement a deleted copy constructor. That's exactly what we were talking about previously. So let me pull this up here. Yeah, the queue disable copy. That's exactly what's going on. We're trying to creating something on the stack here, and then we're saying, hey, here's the object, but we're actually calling the copy constructor in the background. So we can't do that. This just simply won't even work. Super frustrating. Okay, so let's figure out a way around this. Your first thought's going to be pointers, and you're absolutely correct. We could do a pointer. But creating a pointer obviously detracts from our conversation about the stack, so we're not going to do that. First thing we're going to do is test the lifetime. And we can actually grab this guy and let's test this. What's really going on under the hood, and anybody who knows anything about even entry-level C++ is going, this is painfully obvious. We are creating an object on the stack, and then because it's going out of scope, we're destroying that object. That is the beauty of the stack, automatic memory management. Qute's royal pain in the behind is that disable copy, and you've got to get around that somehow, but it introduces some problems. And these are all what I would call stack-specific problems, but at the same time they can go into heap problems. And let's just show an example here. So let's say void mod class, and we're going to say my class pointer to this guy. Now we're going to take this guy and we're going to set the object name. And then we're going to basically say, all right, because it's a pointer, we want to delete it when we're no longer using it. What could possibly go wrong here? So probably help if we had the right class name in there. There we go. Let's run this, see what happens here. Uh-oh. It was created, it was destroyed, double free corruption out. What? Wait, what? We didn't copy it, so what's going on here? You guessed it. We actually treated that like a pointer and deleted it, even though it's living on the stack. So anything that's on the stack should not be deleted. Probably help if I could spell today. There are sometimes that rule's not really applicable, but by and large, when you're on the stack, you should not try to delete something. Let's try that again. Now it just works. And when we close the program, this will automatically be deleted for us. C++ 101, no brainer there. But you'll find this time and time again where somebody's going to say, hey, give me a pointer to this. You're going to say, well, I don't want to work with pointers. I'm going to give you a reference to it. And then they go, well, I'm just going to delete that because it's a pointer and it's no longer used. And then you can't figure out why your program keeps crashing. Super frustrating. All right, so what if we were to do something a little bit different here? What if we were to actually take this guy and say, give me a reference to him. See, now we're being a little smarter here. And if we try to do a delete later, what's going to happen? Let's see. Let's say mod reference. And I'm just actually going to shorten this to mod ref. So let's get rid of this. There we go. Now I don't have to worry about pointers or references to. I just say, here, do something with this, and then it's going to do something. Again, double free corruption because we're playing around with memory. We really shouldn't. So just because we're on the stack does not mean we're necessarily safe. Bad things can happen very rapidly. So the point I'm trying to drive home here is that the stack, as beautiful as it is not always perfect. And some bad things can happen very, very quickly. To make matters worse, we cannot copy an object due to that QDisable copy. So we're almost forced into using either pointers or references. Oh, that gets super frustrating sometimes when you're working with Qt. Now let's talk about the heap or the free store. And let's take a real deep look at this. And when I say deep, I mean we're probably going to break some things. So what is it? It's the heap. The description, it's the quote-unquote free store where you can allocate pretty much anything you want. You're free to do anything you want to do, but it comes with a cost. You control the memory management. And I have to highlight that because some people, yes, even in this course, are going to scratch their heads at that concept. I've had people go through my Qt Core Advanced series where they come back and go, can you explain what a pointer is? I'm a little lost. You should not be in an advanced class if you're struggling with what a pointer is. But anyways, why do you need this? Why is the heap even there? The stack works just fine. Well, the problem comes in, like we saw with QObject, sometimes you can't copy things. And because you can't copy things, you're almost forced to work with a pointer. Pointers are blistering fast. Think about it this way. You are a person. If I were to make a copy of you, think of everything that makes up you as a person. Your muscle, your bones, your lungs, your organs, your eyeballs, hair, everything, even your thoughts, feelings, your hopes and dreams, every little microscopic thing about you needs to be an exact copy, and that takes time. So to save time, rather than copying, what we do is we put a pointer, and I shamelessly stole this off the internet somewhere, that lives on the stack. This pointer points to something on the heap. And if you're in this course, you're probably rolling your eyes going, I know, get to the point. The point is, rather than making expensive, slow copies of things, you can just point to it and then point to a different one. And pointers can point to other pointers, and you can do some really crazy things. But going back to our conversation on design patterns, the more complex you make something, the more error prone it becomes, and pointers add an infinite amount of complexity. Whew. All right, so let's start this off by diving outside of Qt. We're going to say my class, not going to choose a base class, and I'm just going to hit next. This should just give us a normal C++ class. You notice how we're not inheriting QObject at all. Going to just put in some includes there so I don't have to waste a lot of time typing those out. And we've got our my class, and let's actually do a copy constructor. And I'm going to say const my class and old. We tend to take copy constructors for granted, and we tend to let C++ just copy like crazy. And doing that can lead to some really bad things, even if we're working with pointers. Just being overly obvious for anybody that really downloads this. Constructor, there we go, English 101. Now I'm going to add in a little private variable here. And I'm going to put a getter and setter in there. So very, very simple C++ class. There's really no magic to this, but we are going to do just some absurd things with this. So we might break our system. And if this does happen, well, I'm going to take a wild guess that it's going to be a bad alloc error. And what does that really mean, bad alloc error? It means the free store, bring up this graphic, is not infinite. We can't just create whatever we want. We can't create trillions of universes, although that'd be insanely cool. Eventually we're going to run out of memory. And the operating system is going to stop us at some point and say, hey, if you keep going, you're going to crash not just you, but all the other applications, including me, the operating system, so I have to limit what you can do. So you really don't even have full control over the heap. It's actually very limited in what you can do, even though it gives you the illusion that you can do anything you want. All right, to demonstrate this, we're going to, let's go back in here. I want to add another function. And let's say, I need a really good name, something that just screams I know what I'm doing here. Let's say void log. Yes, perfect. The best name ever. QString message. So what we're going to do is we're going to turn this log into just something that prints it out on the screen. And I might actually just do this object as well. There we go. So far, no little gremlins, but we're about to break some things really, really fast. So we've got constructing, and because we're constructing, let's go in and do our deconstructor as well. Constructing, destructing, and let's go ahead and say qint64. That's right, we're going to make something large. Limit is what we're going to call this, and we're going to say numeric limits of the qint64, and I'm probably doing this very, very wrong. I'm just trying to break this. And now I'm going to say, 64 max equals the limit, and I want to actually divide that by some absurdly large number. So really, what are we doing? We're saying, hey, standard library, give me the numerical limit of a qint64, which is just massive. Divide that by some massive number to try to like squish it down a little bit, just to see at what point we will actually break things. And then I'm going to say for qint64 I equals 0, and I'm going to say I is less than max, I plus plus. I'm just going to increment this here. Oh my goodness, what have I done? There we go. And let's toggle indent. There we go. Now it's all beautiful. And I'm going to say mdata append, and I'm just going to append one character. could do this differently if we wanted to. Pad it with anything. I don't really care. And then I'm going to say log constructed. Ah, we are super smart. All right, we have outthought everyone who's ever worked with C++ in history. No, of course we haven't. We're not very smart. We're actually pretty much going to destroy this whole thing. So let's look at our copy constructor here. Not sure if this will even do it for us. Oh, it did do it for us. Sweet. All right, so we've got our copy constructor. Now what happens when we go to copy? Well, C++ comes in and says, take this object and everything it owns and try to copy it. But things are not going to work the way you think they are. So we actually have to manage the copying because we have this data. And we're just going to pretend that this is a more complex data type than what it actually is. A harsh reality is C++ will probably copy that with no problem. But we're going to take ownership of it. Why not? So let's go ahead and grab this little guy here. And we're going to say bang, bang. And let's say I is less than old data. So as long as we're less than the old data, then we're going to go ahead and data. And I'm going to go ahead and get this and say old.data. And I want the at I. So we're just going to do a bit of cloning in here. Uh-oh, why is this suddenly saying we have an issue here? Ah, I know why. Not left. Work with me here. Length. There we go. And then I'm going to log out that we have copied this. So really what we're doing here is we are creating a class, making some data. We have a copy constructor so we can make a copy of this object, and the data will go with it into our copy. And we are just pretending this is a much more complex data type than what it actually is. And because we're destroying this, let's go ahead and say right now this is probably giving some of you old school programmers a real eye twitch. I mean, despite my horrible typing ability. Just because what I'm doing is absolutely absurd, and no one should ever, in the history of human beings, ever attempt to do this just because it's not a good idea. But now we're going to demonstrate why is this not a good idea. Let's go in here. We've made our non-cute. We're done with cute. You know, we've made our non-cute object. We want to be able to copy something because we're super smart at this, right? And we have the full power of the heap behind us, so we can just make as many of these as we want. So we're going to test copying. And I'm just going to say QInfo object nothing too specifically horrendous about that code. And let's jump down here and let's actually create a blank object. And then we're going to test copying. Doesn't really seem like we're going to do anything that violates C++. We can build, everything builds, and if we go to run this, what do you think is going to happen? Look at this graphics here. We're going to create something on the stack, right? And then we're going to create another thing on the stack because we're making a copy of it. We haven't actually talked about pointers or heaps or the free store yet. It's taking a long time to create that copy is what I'm getting at here. Because that's a large amount of information. Eventually this will stop. There we go. So the point I'm making here is that copying is very expensive in terms of memory and time. We took an object, a large object, and then copied it. And if we ran that again, you see that constructing and constructed, which much faster than copying. All right, there's a lot that happens under the hood. There's reasons for that. Let's move on here. So what we're going to do now is we're going to test a pointer. And what I'm going to do is I'm going to actually just copy this right out of my notes. So we're going to test a pointer. We're going to say my class da-da-da, what's happening in C++ gives us an object at the memory location. Interesting. All right. Let's test that, and let's get rid of this little test copy here. So, much faster. We didn't have that nasty copy going on here. Now let's try address of. And we're going to just test address of. There we go. It's going to grab that reference right there. Bang, bang, run this. And same thing, just as fast as a pointer. There's no copy involved at all. Now, so far, we have been working exclusively on the stack. We've been using pointers to and references to things on the stack, this little guy here. We haven't actually moved anything off the stack yet. And this is a conversation about the heap. So let's actually do something here. Let's say void test. I'm not sure what to call this. Test heap. Why not? Now I'm going to say my class new my class, and then when we're done, we're going to go ahead and delete this. That was moderately embarrassing. There we go. All right, so nothing too fancy. What are we doing here? We're just going to do it on the heap, and we're going to say hello. A lot of people think that if we do something on the heap, because we're working with pointers, that it is faster. And, well, sad to say, it is a little bit faster, but it's not as fast as you would think. So let's do this. We're going to create another guy here. And here's where somebody's cringing and going, no, wait a minute, you're going to copy this. And actually, I'm going to do this in an entirely different function, just a test copy pointer. There we go. This kind of does reach back to C++ 101, and I'm sure a lot of people have probably rolled their eyes and go, I know exactly what's going to happen. But there are some of you out there who are probably struggling with this, right? So I'm going to say, what's happening right here? We are making a copy, but what are we making a copy of? We're not making a copy of this class, we're making a copy of the pointer. Let's demonstrate this, just so we can silence all those naysayers who's going to go, no, this is going to take just as long as if we were making a copy. Watch this. Bang, bang. Fast. So, why did that go faster as opposed to an actual copy? So like if we run copy again, you can see how it's taking a very long time, and it's taking an absurdly amount of long length of time. I don't even have words. It's just taking so long. There we go. Because copy is extremely slow, and that's why they really try to force you in C++ land to work with pointers, because it is so much faster. Now we're going to test copying a pointer. Bang, done. Much, much faster. So what's really going on under the hood here is we've created an object out on the heap in this test copy pointer. And then we've created another pointer on the stack that's pointing to that same object. So it's much faster because now you're not copying all that data, you're just copying the little pointer address. So seems very rudimentary, but I had to put this video in because some people are going to sit here and argue that, you know, the heap is faster, or that pointers are faster, or that using a pointer somehow magically means you're no longer copying, and it's just simply not the case. Okay, the last two videos probably seem pretty rudimentary, but I had to put them in there for a reason. We need to manage memory, but we should manage that memory in a way that Qt expects us to, or I should say that Qt wants us to. Now, you can absolutely manage it using the standard library in the C++ way, but Qt has some built-in utilities that make it super simple. So what we're going to cover in this video are memory leaks, stale pointers, and things of that nature, and how easy it is to do this. Now remember, we cannot copy a Qt object, therefore we're pretty much forced to using pointers at some point, and, well, pointers come with their own complexity and headaches, as we're about to see. Let's go ahead, add new. We're going to make a class, and my class, Qt object, next, finish. Probably going to copy and paste the bulk of this just because why not? Nothing super special about this class at all. Just going to go constructed and destroyed. Want to just see the life cycle of this object, and to save a little bit more time, I may just reuse this class over and over again. All right, now we have a simple Qt object. We can take this Qt object and do things with it, but because it's a Qt object, we cannot copy it, so we're forced to work with pointers. Everybody's favorite, right? So let's go ahead and say QList, include QDebug, and include my class. We're going to make a very, very common issue. Fill list. So what we want to do here is we want to say QList my class. Now we can't do this because it's a Qt object. We can't copy it. So now we have to work with a pointer. Ah, super frustrating. So now we've got a list, and we're going to say int max. So really all we're going to do is we're going to create a list of pointers. All right, so pretty simple code. Not going to win any awards for this, obviously, especially with my horrible typing skills. Notice what we just did. We used a very, very bad word, new. Anytime we use new, we are creating something on the heap, and, well, now we have to manage this. We created it, we own it. So now I'm going to say set object name, just so we can see what we're doing here. Now we've got some pretty descriptive objects. We need to just say list append, and we're just going to put that right into our list. Seems simple, seems easy, but what's wrong here? Well, we created these pointers. Now they live in this list. Oh, that means we have to manage this list memory. Oh no. That's right. So what we're going to do now is we're going to demonstrate a memory leak. And we're just going to say QInfo can get rid of that. And then we can say fill list, and we want our list here, and we just want to do 5 of them. Nothing horrendous. And then we want to do some stuff. Actually, you know what? I don't want to do that just yet. We're going to back out of here. What we're going to do next is we're going to say clear. Very simple. I want to make sure this is crystal clear before we move on. But what's happened here? That's right. Clear does not automatically delete these pointers. So we're just going to run this, and we can demonstrate this really, really simply. Remember, our class very simply is going to say constructed or destructed. So when we run this, because we're constructing them, we'll see they're being constructed, but we never get rid of them. We never delete them. See? Constructed. Never called the destructor at all. So those just live in memory. And this has actually gone out of scope already. So they're just living in memory. And well, now because we don't even have the pointers to them, we have no real way of accessing those. So these are just living out on the heap. Now, most modern operating systems, and I have to say most, will track what memory this application is creating. And when the application closes, they'll go out and try to free that memory up. I stress try to free that memory up because it's not really a guarantee. As the programmer, we create it, we own it. So why is a memory leak so bad? Because you have a very short amount of memory the operating system's going to give you. So if we go, there's our stack size. And I'm on Linux, so it's just ulimit on Windows, and I think Mac it might be a different command. But basically, you can Google how to get your stack size. Stack is, well, the managed store, the stack. The heap size, well, that's a little bit different here. You have to look up the specifics for your OS to figure out how much memory you're actually allowed to have. There is an actual upper limit. Most operating systems, even though the heap is just your RAM, it's not going to give you all of your RAM. So if you have, say, 32 gigs of RAM, you do not actually have access to all 32 gigs in most cases because other programs need that. For example, your operating system. So how does all that work? That is a mystery that shall remain, unfortunately. I can't go into detail on every single operating system and what's going on under the hood. And some operating systems do actually contradict what I just said. They will give you as much memory as you need. Anybody who's ever worked with like SQL Server on Windows know that if you run the SQL Server, it will just take literally as much memory as the operating system will give it, even if it doesn't need it. It's extremely frustrating. So eventually, your program will leak enough memory that it will crash. So I'm going to actually call this demo dangling pointer. And what we're going to do now is, you guessed it, we're just going to create a dangling pointer. We can pretty much just grab this. I was going to kind of combine both of those into one, but I want to really detail this. Creating dangling pointers, so we've got our list. We're going to get rid of this, and what we're going to do now is we're going to say, yes, you know what? I want to delete some memory. And I'm going to just say delete list.at, and I want to say 2 because I don't need that anymore, but I forget to actually delete it out of the list. So what's just happened here? The memory's gone, but that pointer's still in our list, because remember, the pointer actually does not live out on the heap. Ooh, that's scary. Where does the pointer live? It lives on the stack. So the pointer is going to point to something on the heap, even though it lives on the stack. Uh-oh. Yeah, you see some danger here. All right, so let's get this. And now let's say, very, very simple, for each my class item in list, and I'm just going to simply say QInfo item, and I want the object name. Let's see what happens here. Dangling pointers are extremely deadly to a program. I don't want to be overly dramatic, but I can't even tell you the number of times somebody said, hey, can you tell me why my code's not working? And this is why. Blop. So what just happened here? We constructed some objects, we intentionally destroyed an object, and we still have 5 objects in our list. 1, 2, 3, 4, 5. Even though we destroyed one, we never removed it. So we get to the 0 position, the 1 position, and on the 2 position, whoop, that's right, our program just went boom. So I realize this is a bit of C++ 101, but now we need to actually manage this memory, and we should manage this in a way that Qt wants. So I'm going to say demo correct. We've been working with a list, so I'm just going to continue on with this list here. And what I'm going to say is, now that we have this list, I want to call Q delete all. And what this will do is take a container and delete all the pointers in that container. This can be very deadly if you don't actually have pointers in there. But then I'm going to say list clear. That will do 2 things. First, it frees the memory. I shouldn't say freeze, I should say deletes the pointers, and then removes the dangling pointers. Now, maybe I shouldn't say delete the pointers, deletes the memory, and then removes the pointers. Now we can simply take this same code, and it's pretty obvious what's going to happen. This should just work without any problems. Ta-da! Now we've got constructed and destroyed all 5 of them. Beautiful. I should probably change this make dangling pointers, but you get the point here. This thing just works beautifully. We are now doing this the Qt way, and the focus here is the Q delete all. That little guy will save you a lot of headaches. Now, you could have very easily gone in and said for each delete the item, but you are really at risk here of running into a dangling pointer, and then you could crash your program. When in doubt, trust this Qt delete all to just wipe out everything in that container, and then you are responsible for clearing out those dangling pointers. I almost wish they had baked right in here, like put an optional, like, you know, clear list for true or something like that. It'd be a lot cleaner if it was all in one line. Now we're going to look at parent-child memory management. This is what really is, I would call, the Qt way of doing things. And it's pretty basic. We probably covered this dozens and dozens of times in Qt 101, but I have to include it here simply because it is so baked into their design pattern. Parent-child memory management is AKA the Qt way. If you're doing something other than this, you need to really ask yourself why. Why are you deviating from their super easy memory management? I've got my class in here, and it does exactly what we think it does from the last video where it just says constructed or destructed. We just want to see the class's life cycle. Let's go ahead and dive in here. And let's go ahead and include the my class. And I'm going to create children here. So I'm going to say void and this is where things get a little bit interesting, because I want to say my class, and I can do a pointer, or I can do a reference to, I'm going to do a pointer, parent. And why am I doing a pointer? Because that's typically what you'll see out in the Qt documentation. I don't want anybody getting super confused, but because we're working with a pointer, we probably should make sure that pointer actually exists. All right, now that we have a pointer to our parent, we can do pretty much anything we want. So I'm just going to say for int I equals 0, I is less than the count, and then I plus plus. And I'm going to say my class child equals new my class. Notice how it says QObject pointer parent equal null. So by default, that's going to be a null pointer, and I want to actually say this is our parent. What happens here is a few things. First, we have a pointer. Second, we have a parent. That parent now assumes memory management of that child. So when the parent's destroyed, all of its children are destroyed with it. It's kind of like a sick horror movie if you think about it. The parent's like, if I'm going to go, I'm taking all of you with me. And it's kind of a morbid way to think about it, but it really is kind of how that works. So I'm going to say child. I want to set the object name, and I'm going to say child. Nothing really super complex about this. You've probably done this code hundreds and hundreds of times. So we're going to take this create children, and we're going to actually work with it here. So I'm going to say testing the cute way. First thing we're going to do is we're going to make a parent. So I'm going to say my class parent. Going to give it a null pointer, and let's go ahead and call this the ever descriptive name of parent. So now I'm going to call create children, and I'm going to say parent, and I want to create 5 of them. You have 5 children. Now, if you have 5 children, you've got bigger problems. Probably money issues would be my guess, but neither here nor there. Let's go ahead and just test this out. Notice a couple of things right off the bat. First, the parent here is on the stack. These are on the heap. But let's go ahead and run it and see what happens here. Sure enough, we've created that, and then we have created all these children, and then we've destroyed the parent, and because the parent was destroyed, all the children were destroyed with it. That is extremely cool. That makes memory management so much easier. And again, I'm almost ashamed to even put this video in here because you should already know this if you're working with Qt. But just in case you've skipped beginners, intermediate, and advanced, and you somehow here, this is how the parent-child memory management design pattern actually works. And if you're not doing this, stop, ask yourself why. This is the Qt way of doing things. Now, the other problem we end up having is, now that we have children, how do we interact with those children? Well, let's play around with this a little bit. I want to list my children, all 100 trillion of my children. All right, so I want to say my class, parent, and then I'm going to say, if not parent, return, and I'm just going to grab this. I'm going to list those kids out. And this is where I'm going to say simple for each. Ta-da, there we go. Now, you know something right off the bat. Cannot initialize variable type my class. What is going on here? You might have run into this and said, hey, I don't understand what is going on. What happens under the hood when you add that child in there? It gets cast as a Q object. So now we have to do some casting. Suddenly, now it says, oh, I know exactly what you want. Oh, that's frustrating. So now what we should do is say QObjectCast, and I want a my class pointer to obj. Now you should probably put some like test to make sure we have a pointer. But just for demonstration purposes, I know this will cast just perfectly fine. QObjectCast is how you would say, I know this is a QObject and I want to cast that from one QObject type to another. So because our child, ta-da, is a QObject, we can use that and it works just beautifully. So we've got create children, we're going to list children. All right, so listing children, and then there is our children in all their glory, and then we're go ahead and we're going to just destroy them. So now we can access individual children in there. I want to take this just one step further, and I want to try to find children. So let's go ahead and say find children. I should say find child. What we're going to do next is we're going to say, let's find a child, one specific child in that list of children. So again, we can just simply say, all right, let's do this. QList. Now, if we try to do my class, we're going to get an error. So let's say QObject pointer. And then we're going to say parent find children. And we say find child, but I'm going to do find children just in case there's more than one. And then I want to give it the name. So you might be scratching your head going, whoa, 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 what's name? Why are we asking for a string? Well, if we look up here, set object name. So what we're really looking for is child and space a number. So we're going to get back a listing of children. And that's why I wanted to do find children, just in case you name multiple objects with the same name. They're independent QObjects. They can't be copied, remember. They're independent QObjects, but you can name them the same. So now you can have multiple objects with the same name. You can have two children named Bob or two children named Alex. All right, now that we've got our list of folks here, we can just say bang, bang, let's grab this. And we're going to go ahead and just cast that out, and there's our child. And we're going to say found. Makes it super, super simple to work with children. All right, so in here, we could list the children, and then we're going to say find child. And I want to find child 2. Save and run. Let's see what this finds. So we found one child, and there is the child that we found right there. And everything works beautifully. We don't have to worry about memory leaks. We don't have to worry about any dangling pointers or anything of that nature. It just works as expected. Okay, we're going to talk about resource acquisition is initialization. And what does it really mean? And while you can read this whole thing, shorthand, what it means is allocation is done during the creation of an object, and resource deallocation is done during the object's destruction. So when you create an object, you gather the resources. When you destroy the object, you release the resources. And let's look at a pretty solid example of that. See, solid example, no pun intended. or was there a pun intended? Anyways, so we're going to go to a console app. We're going to say Qt5 design patterns, and this is 4-5. Bang, bang. And just going to put some notes in here. And it says it makes it easy and Qt follows RAII mostly, not all the time. So we're going to make a simple server. When I say simple, there's actually not a whole lot simple about this. If you're a beginner, this is going to make your head explode. Just fair warning. So we're going to add in networking. And I want to actually put that in my notes. Because sometimes people will download this code and they'll not understand why it doesn't work. So we have got our main file, and we're going to actually make a multi-threaded TCP server using a thread pool. Whew, say that after a few cocktails. Okay, so because we're going to be working with the thread pool, we need to kind of do things a little bit differently. And we're going to go add new, and I want to add a class. I'm going to say my connection. And in our connection, we're not going to make this a Q object. We're just going to have this as a normal C++ class. And now we're going to add a new my server. And this, of course, will be a Q object. Now, there's a reasoning behind this. It just makes it super simple. And the connection is going to be a Q runnable. And Q runnable is not a Q object. What? Okay, so think of it in terms like this. The connection is the actual connection, the TCP connection. We're making a wrapper around it to handle that thing. So I pasted some includes, QObject, QRunnable, the socket, debug, and thread. So yes, we're going to be working with sockets and threads in this video. And right here, we're going to just say QRunnable. And if you've worked with thread pools before, you know these things are pretty sweet. We're going to add the run function. So what happens under the hood is you'll create a runnable, you'll hand it off to the thread pool, and the thread pool will call run in the background here. And when we call run on this, it's going to actually be on a separate thread. So pretty cool how that works. I'm going to get rid of that little guy there. And I'm going to say, why does it say public? That's annoying. All right, so we're going to say void handle, or actually let's do set handle. You know, there's probably an easier way of doing this. Sometimes I just like to argue with the editor. I don't know why. So we're going to say socket, and we're going to make a pointer called msocket, maybe. There we go. And then we're going to make a q int ptr called mhandle. And then we're going to create a getter and setter. Now, notice this has to be a pointer. Q object, and there's a reason for this. I'm just going to paste my notes right in there rather than try to type all that. Q objects cannot move threads easily. And what I mean by that is if you create an object and then you try to move it to a different thread, which you've probably done hundreds of times, sometimes that doesn't work too well. So you get what's called a cross-thread operation. QObject cannot create children for a parent, keyword parent, your parent-child hierarchy, on a different thread. So if you have threads A and B, and you try to create a thread on B with a parent of A, bad things happen. Seems super confusing because it is super confusing. Let's switch over here, and let's actually flesh this out. And we're going to just go right here. I'm going to say QInfo. Whoops, don't know why I even did that. And QThread. We want that current thread. So we want to know what thread we actually did it. Do not create the socket here. We're talking about RAII, but you would think, hey, we're creating this, we should create it here. No, do not do that. Why? Because this will be created on the original thread with the parent, and this is going to be shoved into the thread pool as a separate thread. Oh, that gets frustrating. So now, because we're working with RAII, we need a deconstructor as well. Now, somebody out there is probably screaming, well, if you're not doing it here, it's not RAII. The shorthand version of RAII is that you use the resources, or you create the resources when you need them and you get rid of them when you no longer need them. You're not holding on to resources through a full object lifecycle if you don't need them. And we're going to demonstrate that. So I'm going to say, just grab this guy. So we destroyed that, and I'm going to say if msocket. So if we have a socket, we're going to say if msocket is open. We're going to go ahead and close that. And then we're going to get rid of that socket. So super confusing. Is this RAII? Yes, and here's why. This may be the constructor of the class, but this is when the class actually gets run on a thread. So this is where the execution starts. Gather the resources here. And we're going to say execution ends, release the resources. This is why RAII gets a little bit confusing, because you're going to be inclined to do it here, and you really shouldn't, because we're going to have a cross-thread operation that will completely break this thing if we try to do it some other way. All right, so I want to add in another little guy called handle connection. And then I'm going to right click and bang. There we go. I'm going to move this right up under here so we can see very easily what's going on. So when run is called, this is what we need to really focus on here, is we're going to start running on a different thread. And that's why I've got this current thread, because you'll see when we run this how that thread is going to actually change. Now we need to do our RAII, meaning we need to actually create that socket. And now we've created a pointer. This is kind of the pain part here. Because we're working with a pointer, now we have resources we need to track. This gets super frustrating. And we're going to set descriptor. There it is. And we want to get the mHandle, which we're going to set when this thing is created. And we are going to wait for disconnect, or actually wait for connected, sorry. Wait for disconnected. We'll be there a while. And then we're just going to handle the actual connection. So when this is run, this is going to be on a separate thread inside the thread pool, and then anything that we call is also on that separate thread in the thread pool. That's kind of why I broke that up, so you could see that, hey, anything you call on the thread stays on the thread, unless you specifically try to move it off, at which point it may explode. All right, now we're going to handle this connection. We're going to say q byte array. And let's call this data. and I've got some code. I'm just going to the old copy and paste, bang. We're going to just say data append hello world. We're going to write it. We're going to wait for those bytes to write, and then we're going to close that socket. At which point, the runnable has nothing to do, and the thread pool automatically will delete this because we're going to set this to auto delete, which means it's going to come up here on yet the main parent thread, and it's going to release this bad boy, and that socket's going to have to be deleted. So there's our full object lifecycle for that socket, or RAII, is it starts here in run and ends in the destructor. Again, we didn't do it here because we'll have a cross-thread operation, and it's going to get really ugly if we try doing that. Whew, super confusing, but that's why I'm doing this example and not a very basic class, because someone somewhere will try this and then wonder why they have all sorts of issues. So let's go into our server. Just going to paste in the includes. We have in order QObject, QTCP server, QThreadPool, QThread, QDebug, and our connection class. All right, so let's go into slots, and I'm going to say void, and I want about to quit. And now we want to actually go in here and say QTCP server, because we are making a TCP server. And now we need to handle this incoming connection. And again, this is very error prone depending on what version you have, so always trust whatever type it's putting here. If you ever have an incoming connection that never fires off, that would be why, is the type is wrong. This used to be like a QINT64, an int or something like that. So as they've moved from one version to the other, it's gotten a little bit finicky here. I'm missing our about to quit. There we are. All right, so our server, super simple. We're gonna just kind of dumb this down just for the sake of time, or we'll be here all day. Closing the server, and we can go ahead and close this. Not sure if we're even going to use that. I just want to add that in case somebody downloads this and decides they want to use it. So we're going to go ahead and make our runnable my connection, and let's call this client. Oh, memory leaks everywhere. So I'm going to actually put in danger, no pointer, or a pointer with no parent. So why are we doing it this way? Because if we try to set the parent, we're going to have some sort of cross-thread operation. Frustrating. So this is how we do memory management for the thread pool. We're going to say client set handle. That way we can get the handle of the incoming socket connection. In case you're really super curious what that is, it's just a number. The OS says, hey, here's a number, and it may be like 1655, 255, 6000, whatever, of whatever socket on the underlying operating systems that's sitting there waiting for the connection to be accepted. But now we want to do our memory management. So we're going to say set auto delete true. And I believe this is true by default, but I simply don't trust it. So I always set auto delete true. Then QThreadPool. And I'm going to say global instance. That's right, every single app has its own global instance. And I'm going to say client. So we're going to start our runnable. And I'm going to just copy and paste in some notes. So if somebody downloads this, they're not completely clueless what we're doing. So in order, incoming connection fires off from our server. We make a client, but we are in danger because we have a pointer with no parent. So we need to manage that memory. We're doing that here when we're telling the thread pool to take ownership of that and delete it when it's done. And then we're just saying, hey, set that handle. So inside of our actual connection object, when we run, we can actually set the socket descriptor to the handle. So we tell the underlying OS, hey, you gave me a number of 55. I'm going to go ahead and take ownership of that socket, and I'm going to now read and write the data out of that socket. Whew, If that seems confusing, it's because it is. Socket programming's always been a pain for just about everybody everywhere. So let's jump back in here, and now let's make this thing actually work. So we're going to say include QObject and include my server. Need some screen real estate here. There we go. And I'm just going to say my server. And let's go ahead and call this server. And now we're going to simply connect signal and slot up. So I'm going to say QObject connect. And I want to connect to this QCore application. And I'm going to say I want the QCore application about to quit. You were wondering where that was coming in. Okay, so now when the application is about to quit, we're just going to simply shut that server down. So we're going to say server, and we want the my server about to quit. So when the app stops, the server stops. Otherwise, this thing may hang in the background indefinitely until we force it to stop, and that gets super frustrating. If not, server. And I want to say listen, and I want Q host address any. You can change this to whatever you want on your operating system. And I'm going to do 3372. Again, pick a port that's not in use and isn't going to piss off somebody's virus scanner. And I'm going to say server dot error string. In case you skipped it, I did have a video that I made where I used a port, and I had no idea at the time. And the port was known to be a virus port that a common virus used, and I didn't even know about it. And so somebody said, hey man, you infected my system. I typed the code exactly as you typed it, and now I have a virus. And I had to explain to them that's not how this works. All right, so our server in all its glory, let's give it a good build, make sure we didn't screw anything up because that was a boatload of typing. And there's a whole lot of scanning and stuff going on. Let's do that again just to make sure. All right. And listening. All right. What port did we do? 3372. So I'm going to pull open Telnet. And all right. There is our full socket lifecycle there. So listening, and then it was constructed on this thread, and then it was constructed on this thread, and there is our actual client right here. And then constructed everywhere. Let's redo all of that. I got a feeling I got a little copy and paste friendly. Destroyed, yes. Not constructed running. Constructors everywhere. That's embarrassing. Super easy to fix. All right, let's try that one more time. So it is now listening. Let's pop, where are you? There we go. Didn't want to work with me there. So we're just going to telnet into that server, and that should be a little more easy to understand here. So we have constructed on this thread. We are running on that thread. It is now pooled. We're handling that connection, and then we're destroying. So there is our full object lifecycle. Now, the whole point of this isn't really cross-threaded TCP server operations. The whole point of this is RAII, resource acquisition is initialization. And what that simply states is create the resources when you need them, destroy the resources when you don't. And they take it a little bit kind of a written in stone approach where they say resource allocation is done during the object creation by the constructor, while resource deallocation is done during object deconstruction by the deconstructor. But this is an example of when you simply cannot do that. If we were to go into our connection and create the socket here, we'll get a cross-thread operation. So we simply can't. So we do it at the earliest possible point, which is when the thread starts or the execution starts. This video we're going to talk about QScope pointer. It's a smart pointer in Qt that, well, does exactly what it says it does. It only lives as long as it's in scope. So as soon as it goes out of scope, it automatically deletes the pointer that it has inside of it. If you know QScope pointer and you're an expert in this, go ahead and safely skip this video. But if you have any questions or concerns, pay attention. So we're going to jump in here. We just have a very simple class, which admittedly is extremely simple. We're just going to monitor the life cycle of this thing. And I'm going to put in a QString and a QString. Switch back here. And through the magic of copy and paste, we're just going to go bang. So I'm not wasting a lot of time here. So really, when we create this class, we're saying, hey, give us a name also, and we're just setting the object name. That way, when we print out this, it will say the name of the object. So we can name it whatever we want. And we may reuse this class in future videos. But it's just constructor, deconstructor, and a test function. Not super, super complex. And now we're going to go in here, and let's just add in some includes. QDebug, QScoped pointer, QScope pointer array, and the my class which we just created. So without further ado, what are we going to do here? We're going to say my class, we're going to break some rules is really what we're going to do. And we're going to say make class. This is going to be horribly misspelled, but we're going to just say, for example, this is some library that we're talking to. A lot of libraries do this where they'll say, here, I'll just hand you a pointer and you now own it. Oh, that's frustrating when they do this. You'd be surprised how many applications in lib do this, even though now we have potentially a dangling pointer out there. So we're going to say return new my class. And this is a null pointer. And let's go ahead and give it a name as well. And I want to say so this is just some library or some code somewhere that we're interacting with, and it's just handing us a pointer, and now we have to take ownership of this pointer. And this is where QScope pointer really comes into play here. So we're going to say test scoped. And we're going to take ownership of the pointer. We can take ownership as soon as we get it. So we're going to say QScoped pointer. This is a typed, so I'm going to say my class. And let's call this P for pointer. And then we have to actually give it the pointer. In this case, it's the make class. And let's call this my smart pointer. Some long, obtrusively long name. And notice how we don't have to mess around with, hey, there's no star in here or anything like that. It's not like this. We're just basically saying, create a QScope pointer of this type and give me the pointer. That's all we're doing. Now, from here, we can do whatever we want. And this is the really cool part, is we don't have to say like pdata.test. We can actually just call that test function directly and just treat this as if it were just a normal pointer. That is insanely cool. We could also, if we wanted to, access the raw pointer itself. For example, we can say my class ptr equal p.data. Oops. And that gives us the pointer to the class. However, typically you don't want to do this because now you are in memory management land. And that's the whole point of this, is we don't want to have to even think about this pointer. So what happens? How do we delete this pointer? Well, it's a smart pointer. So once this goes out of scope, this guy right here, once it goes out of scope, everything is removed automatically. It's so cool. I love automatic memory management. Don't even have to think about it. So let's go ahead and test this. Save and run. And you can see constructed, test called, and destroyed. So we have our full object lifecycle right there, and we never had to delete anything. It just does it automatically. That is so cool. Now, as with almost all of our videos, we're going to take this to a more difficult realm than the simple this is a scope pointer. So we're going to actually test an array of scope pointers now. So we're going to say void test scope array. And let's go ahead and we're going to make an array of smart pointers. And we're going to say we want a maximum. And let's go ahead and say Q scoped pointer. Q scoped array pointer. Boy, that's a mouthful. I wish they'd shorten that. My class. In case you're wondering where I got that from, it's from the includes that I copy and pasted up here. And Q scoped array pointer, you guessed it, just holds pointers in an array. It's really not rocket science here. A little bit different though. So we're going to say here, and we're going to say p dot reset. So we just want to force one in, and we'll say new my class. Max. So we're going to initialize our array. Now we don't really play around with arrays too much in Qt land, but in normal C++ land, arrays are like all the rage. They're the snazzy thing that everybody likes to work with. And that's why this class Q scoped array pointer exists, because we want to actually work with an array of pointers. So for int I equals 0, I is less than max. And then I'm just going to say p I equal, actually, let's say test, because it should already be in there. And then again, when it goes out of scope, everything's removed. Let's go ahead and test this, and let's grab that. Save, run, and let's see if this works. Sure enough, we had a whole bunch of constructed, a whole bunch of tests called, and a whole bunch of destroyed. So our automatic memory management is working as expected. That is just insanely cool. So if you ever have some C++ code like from a library or somebody's class and they're handing you an array of pointers, this is how you would really tackle that. All right, so let's go ahead and do a smart list cleanup. And let's say, I have to explain this a little bit. So with the QScope pointer, we can actually determine when we delete, when this deletes, we can actually make our own function and determine what happens when it's deleted. And that's really what we're going to do right now. So we're going to say this struct calls the myCustomDeallocator to delete the pointer. And that makes 0 sense in the moment, but bear with me. So we're going to say struct, and I'm going to say smart list cleanup. So we're just making a struct. And I'm going to say static inline, and I'm probably doing this horribly wrong. Somebody out there is probably screaming at their monitor saying, no, there's a better way, don't do it that way. And inside of our inline function here, I'm going to say QList myClass, and this is going to be a pointer to a list. And then I'm just going to call Q delete all. And then we're going to clear that list out. Probably a vastly simpler way of doing that. So now that we've got this structure with our inline function, what are we going to do here? Well, we're going to make a custom deleter. So let's go ahead and go void test custom deleter. And there we go. Test our custom delete. And I'm just going to comment this out real quick. All right, so now that we're here, we're going to say QList my class, and it's going to be a pointer. And I want a QScope pointer. And this is where things are going to get a little weird. I'm going to put those in there so you can see you need to have this, because this kind of screws people up sometimes. QList. And then again, my class. And now we want to give it our custom deleter. In this case, it's going to be the smart list cleanup that we just created up here. QScope pointer, say that 5 times real fast. QList pointer my class, and then we're going to call a custom deleter. Whew, man, that is confusing. All right, so P, and let's give it the list. Wow, that is a handful. So, and we could actually put some sort of like, you know, we're going to delete or something like that. We could say like QInfo. That way people believe this actually works. Let's just call it custom cleanup. There, we're more professional now. Marketing's going to love us. Custom cleanup. All right, and then we're going to say for int I equals 0, I is less than, I'm just going to pick a number 10, I plus plus. And let's say list.append, and we want the trusty make class because we're going to get a pointer, and I'm going to say list. Got to give this some special name. It's got to be a name that everyone's going to know and love. QString number, and we're just going to do I. So we're just making a list of pointers. Nothing super special about that, and we can do stuff with our list. So for example, we could do a for each, and let's say my class. And then I'm just going to say item test. So we can just, you know, interact with those pointers as we need to. Now, here's the interesting bit here. This list, as long as I didn't screw something up, automatically clears and deletes the pointers because we have this smart cleanup here. So if we look at QScope pointer, ta-da! Let's go up, up, up. So QScope pointer, type template, type name T, type name cleanup. So that's really what we're calling is our cleanup function. It's actually really cool that you can do this. So then if you had some custom scenario where you wanted to go in and deallocate other resources, like you're using RAII or something like that, you could go in and actually do some custom code. You're not reliant on Qt to do it for you. So let's go ahead and test this, assuming I didn't screw up any of the typing. Bang, there it goes. There's our custom cleanup right there. So we have a bunch of constructed, a bunch of tests called, and then wham, automatically destroyed through our custom cleanup. Pretty cool. The last video we talked about scope pointers. The problem is a pointer's meant to be shared. That's the whole point of pointers. Get it? The whole point of pointers. And sorry, I won't quit my day job. Anyways, a shared pointer or a QShared pointer is a Qt smart pointer class for a pointer you intend on sharing with others. And this example will probably hurt some people's feelings and maybe even hurt their brains. I know it hurt mine when I wrote it. Let's just dive into it. So basically, we're going to make a pointer and we're going to share that pointer with other objects. And we're going to say 4-7. Got some notes. There's going to be a whole lot of copy and paste action here. All right, so what are we doing? Shared pointers, pointers that auto-delete when go out of scope. But we're talking about shared. Now scope, we're loosely defining this, so we should change scope to when no longer used, and instead of but, and can be used more than once. So I changed the official description a little bit here, but I think you get the point. So let's look at how we would actually use this. First things first, we're going to make a my class. I know, our infamous my class here. And we're going to go into my class, and I'm going to just copy and paste some includes in here. Bang. QObject, QDebug, QThread. Ah, see, you slowed down. We're going to do some threading. And QMutex. Ooh, mutexes are often confusing. I personally don't like working with them because I always screw them up. As I'm sure many of you know who you are, do as well. Alright, so we're going to right click, add our deconstructor in here, and then we want to just add some stuff. So let's go down here. I want to add an int mcount and our QMutex. And I am probably going to screw this way up to the point people are going to be like, whoa, that's not how you're supposed to use a mutex. And I'm going to say add count and QMutex. Alright, so let's go ahead and add that in. Add this in. And add this in. It would be super cool if you could just like grab all of these, right click, and then add them all in, but it just won't let you do it. Alright, so inside of my class, this is where we're going to just rip out some copy and paste. So we're going to set the count to 0. We're going to say this object's been constructed on, and then the current thread. Nothing super special about that. Same thing with our deconstructor. Final count, whatever it is, destroyed on whatever the current thread is. And then our count here is just going to return the mcount. The add count, this is where I'm going to actually type. We're going to say QMutex locker. We're going to call this locker. Again, this is not a beginner's class, so if you're going, whoa, explain the QMutex locker, I did that in the advanced series. So QMutex locker is just going to take that mutex and lock it. Going to increase that count, and then I'm going to say, through the magic of copy and paste, bang, count is the count on whatever thread we're on. Wow, I screwed that all up, even with the copy and paste. And then our super snazzy mutex here. Did I say mutext? I did. Wow, that's embarrassing. Let's go fix that real quick, or it's just going to bug me. There we go. All right, so let's give it a good build, make sure everything's lining up. And if our copy and paste and typing skills worked and the sun, moon, and stars all align, everything should just work. Now we're going to make a runnable, and we're going to put this class inside the runnable. I'm going to say add new, and we're going to say class, and this is going to be a my runnable. Usually when you have a runnable, it's not really something you want to advertise to the world. It's a little bit embarrassing, especially if you're in public, but you know, we're coding, so why not? And we're just going to paste a whole boatload of includes: QObject, QDebug, QMutex locker, QThread, QRunnable, QSharedPointer, there it is, QRandomGenerator. I love this class, especially for testing, because it just makes random numbers, and then our my class. And from here, we're going to, you guessed it, implement the runnable interface here. Bang. And because this is super annoying having two publics in a row, I'm just going to do that. And I'm going to say Q, and I want shared pointer of my class type. Let's go ahead and right click, add that in, switch back, and let's go ahead and set the pointer. And probably could have done this using the GUI, but sometimes I just want to slow down and explain things a little bit here. So we just got our getter and setter. And then we can literally just take this and then copy and paste. So what's really happening here, and this is why I wanted, instead of doing this and then right-clicking and adding, getting, etc., I wanted to slow down and really explain this a little bit here. So what we're really doing is we have a private variable of a QShared-pointer, which is of, or I should say, going to hold the type of a my class. We have our getter and our setter, meaning we are now sharing this pointer. We're passing it around, and there are pointers everywhere. It's kind of like watching Oprah Winfrey. Pointers, you get a pointer, everybody gets a pointer. So in our run, we're going to say for int I equals 0, I is less than 10, and then we're going to just simulate some long activity. And then I'm going to say int ms equals q random generator global bounded, and I'm going to say 0 to 500, so anywhere between 0 milliseconds and half a second. I'm going to say the Q thread, the current thread, I want to actually sleep. You know, sometimes you just want to take a nap. You've had a long day. You just want to lay down and go, I'm done with today. And I'm going to say endpointer, and then we can just say add count. We could have done endpointer data add count, but this is just more convenient. And then in here we have our getter and setter. So we're going to say return. All right, so let's give this a good build. Make sure we didn't screw anything up. So far, so good. Now we have our class, we have our runnable. Let's go ahead and push this off onto a thread pool somewhere. Now, when we run this, we're going to have to make sure that we have set this pointer first, meaning this pointer, this QShared pointer, is going to come from somewhere else. So we cannot use QScope pointer, or it would have gone out of scope. We would have to hand a pointer to a QScope pointer, which wouldn't make any sense. That's why QShared pointer exists in the first place, because we're going to just pass this thing around, and in doing so, it would go out of scope. Whew, that's a mouthful. All right, let's flip back to our main here. Magic of copy and paste. I love copy and paste. Best invention ever. Qdebug, Qthread, Qthread pool, QShared pointer, our class, and our runnable. Let's go ahead and build out our test function. And before we get any further, I'm going to actually call it down here. I have a nasty habit of saying, all right, let's do this, and then I run it, and I just never put the function in there, so nothing happens. So I'm going to put some stars in here just so we can see like a visual cue on the screen, because when we're working with threads, things might not go as we want. So entering and exiting, we're going to see the scope of this. And now I want to say Q shared pointer. All right, so we're creating the shared pointer. We now have this variable in this scope that has the class pointer in it as the data. So if we were to use QScope pointer, it would be deleted here when this goes out of scope. But we're using a shared pointer, so we can use this whenever we want. Whew. All right, now for the tough bit. and I want the QThreadPool global instance, and I want the max thread count. And from here, I'm going to say I++. So really all we're doing is saying from 0 to the maximum thread count, let's do some stuff. And we're going to say myRunnable. Screwed that all up. myRunnable. There we go. Again, people are going, wait a minute, we have a dangling pointer there. Well, what we're going to do is we're going to say runnable set auto delete, and we're going to make sure that's true just because I am very untrusting of platforms. I love Qt to death, but don't get me wrong, I love it to death, but I don't trust it. So I'm going to set that to true. I'm going to say runnable, and we're going to go ahead and set the pointer. And this is going to be our, you guessed it, Q shared pointer, my class. So what have we really done there? Well, we've taken this from one scope to the other, and we've passed that data back and forth. Very cool how that works. And then we're going to say QThreadPool. And we're going to grab the global instance again, and we're going to just start our runnable. Bang. So what's going to happen when we fire this bad boy off is it's going to start here, go to test, go up here, you're going to see entering, it's going to create some threads. Each thread is going to, when we go into our class here, actually let's go into the runnable first. It's going to go in here and then it's going to say, hey, I want to take this current thread and sleep for a certain amount of time. And that's why I put these stars here, because you'll see that this will go out of scope and those threads are still living in the background. Whew. All right, so anyways, and then it's going to say pointer add count, and then it's going to go in here. And add count's just going to increment it. And because we're working with threads, I wanted to use a QMutex locker. Not making any solid guarantees that I've done that correctly, because really what we're focused on here is, you guessed it, the shared pointers. All right, let's save and run, see what happens here. And it's just going to go and go and go, and then destroyed. All right, so if we go up here, you can see entering, exiting, and then did a bunch of stuff and then destroyed. Bang. So the final count was 80 and it's incremented it, hopefully correctly. But what you can see here is that this thing just works, and it works the way you'd expect it to. So not super hard, and we don't have to really screw around with memory management. And before I close this, let's just assume I screwed something up in this code somewhere, somehow. When this application's destroyed, it's going to go through and try to, because we have this in here as a Q shared pointer, it's going to try and wipe out that memory for us. Pretty cool. Okay, so far we've talked about Qt-centric technologies, but it doesn't mean you have to use Qt. There are smart pointers baked right into the C++ standard library, and this is just what we're going to demonstrate here. So if you're already familiar, feel free to skip this video. Specifically, we're going to cover unique pointer and shared pointer. So I've already got a test class out here, and very simple. It's got a constructor, deconstructor, and a test, and it really doesn't do anything special. It's not curing cancer, just constructed, destroyed, and then some sort of value. And we can actually just fix that a little bit here. All right, so let's dive on in here. And first thing we're going to do is get our includes. And we're going to including Qdebug, IOStream, memory, and my class, this guy up here, and using the namespace std. From here, we're going to create some functions. I love functions. So void test IQUE, we're going to test unique, and then we're going to test shared. And let's just dive into our unique function here. And I'm going to say QInfo and I'm going to say I want the unique pointer, And as I'm typing, you may be wondering, wait a minute, if this stuff is already baked into the standard library, why does Qt even bother to do it? Well, you have to remember that some of the things that Qt didn't even exist in the standard library when Qt made them. Qt made them because there was really nothing out there. That's actually why Qt was created right from the beginning, because there really was not a solid cross-platform GUI system, for lack of a better term. All right, so from here we're going to say P1 equals, and I just want to see what this looks like. So P1 get, and we can actually call the P1 test. Super simple, super easy to use. I mean, the standard lib. The real question now becomes, which one should you use? Well, that's a good question. So personally, if I'm working with Qt, I will stay with Qt-centric technologies, and I'll sprinkle in the standard library as needed. If I'm in the standard library, I will avoid Qt at all costs, simply because the standard lib typically doesn't know how to handle Qt stuff. All right, so what we're doing now is we're making a unique pointer, my class, called P2, and we're moving or taking ownership of this. Remember, this is a unique pointer, so only one. There can be only one object. So we have to take ownership of this bad boy. This is how you ensure you really don't have some sort of dangling pointer out there. And now that we've taken ownership, what we need to do is test these real quick. So I'm going to say P1, P2. This should be set to null. I should say null pointer because it's different than null. And then we're going to test P1. Pretty silly little test, but it really just, explains everything. I'm just going to say test the pointers. So we're going to say P1, and then let's test P2. That'll get super confusing if I don't change that. All right, so now we're going to just call this function here. Save and run, as long as I didn't screw up the typing. Voila. So we have the classes constructed, P1 equals this, and then from pointer 1, and then we've actually taken ownership on P2, and you see how P1 is now an Q object of 0, 0, meaning it's now a null pointer. There's simply nothing there. And then we have destroyed it. So that is the unique pointer. There can be only one. I always think of, what's that show with the sword? Highlander. There can be only one. Those of you who have never seen Highlander probably have no idea what I'm even talking about, but it's basically like he's this immortal guy with a sword, and he absorbs the souls of other people by chopping their heads off. So it's not a kid's show at all. Anyways, there'll be no head chopping here. So now we're going to test the shared pointer, and I'm going to just, before I forget, because I know I'll forget. Isn't that bad when you know you have a nasty habit, you just can't seem to break it? All right, so now we're going to say the shared pointer, my class, P1, and this is going to be a new my class. And then we're going to just grab this guy, and we're going to make P2. But we're going to say P2 now equals P1. That's right. So we're basically taking this variable and pointing it to the other pointer, or I should say both of these variables now point to the same instance out on the heap somewhere. Seems a little confusing, and it's kind of hard to wrap your head around. And then I'm going to just grab this, get rid of that because they both should point to something, right? And then I'm going to test those pointers. And we can also see how many references there are. So I'm going to say QInfo, and I'm going to say ref count. And then I'm going to say p1.useCount. And that should give us a count of how many other variables are pointing to that, how many references are out there. And in case you're wondering, yes, under the hood, that's exactly what's happening. It's reference counting. And once the reference count gets to 0, then the actual class is deleted off the heap. So, save run. See, I totally forgot to check if that was there. I'm glad I did that. So, testing shared, and then P1 and P2 both point to the same thing. And then we can use both of them independently. And we have 2 reference counts. And then once both of those are no longer referenced and the reference count is hit 0, bang, it's destroyed. Simple, easy to use, but you have to remember this probably didn't exist, or it didn't exist the way Qt wanted it to back when they created their smart pointer classes. And I fully expect that as time moves on, Qt's going to start deprecating those Q smart pointer classes and getting rid of them, and they will start favoring the standard library, would be my guess. This is Qt 5 Design Patterns Section 5. This section deals with signals and slots. And on the surface, this may seem very basic. I mean, after all, signals and slots are the very bedrock of Qt development. We're going to deep dive into this. We're going to talk about connecting, disconnecting, the connection types, and we're going to make an auto connection class. So we don't even have to connect the signals and slots. It will just happen automatically. We're going to look at child events along with the sender function and signals and slots inside of libraries. All right, we're going to take a look at signals and slots. And I know some of you out there are groaning and going, oh, I already know signals and slots. Very, very true. We're going to take a look at signals and slots, mock, and some of the code that gets generated here. So I've got some classes, and we kind of take signals and slots for granted here. Because you got to remember, these were created back when either there really wasn't a signal slot mechanism or it just sucked. It was like more of a callback sort of thing. So anyways, I got 3 classes. Producer, which will produce something. Consumer, which will consume it. And the my class, which of course is just a very simple constructed, destructed, and do something with it. So let's dive into our producer real quick. I'm going to grab some includes. QObject, QTimer, QDebug, QSharePointer, and my class, this little guy. And let's go ahead and fill these in. So first thing we want to do here is create some slots. So we're going to say public slots, and let's say void start, and void stop. And then for our signal, we're going to say void ready product. And this is going to be a Q shared pointer of the my class. And let's just call this PTR. Now I want a private slot in here as well. We'll see why here in just a second. As soon as I can figure out how to spell the word slots. There we go. We'll say void produced. Let's go ahead and implement these. All right, and flip back one more time, and let's just put a timer in here. And you probably guessed already what we're going to do, so I'm not going to waste a lot of your time doing this. mtimer set interval, we're going to set this at every 3 seconds, and we're going to connect the 2 objects, the timer, QTimer's timeout signal, to this producer produced, our slot here. This is our private slot, so no one but us can see this little guy. And then I'm just going to say in start, Wow, even screwed that up copying and pasting. That's embarrassing. And then in stop. So pretty simple. We're going to say, hey, we're starting, start the timer, stop, stop the timer. And then in produce, this is where the magic is going to happen. So I'm going to actually type this out. I'm going to say qinfo this producing item. And then now I'm going to make a Q shared pointer of my class. You kind of guess that is what we're going to do. Boy, I really screwed that up. All right, equal new my class. And then I'm going to emit that product ready, or I should say ready product. And then we could just say something like item produced. That way we know we've actually done our full production cycle here and we don't need to do anything else. So now we've created this my class, and you remember our my class just simply says it was constructed or destroyed. So it's going to say constructed, and then we can do something with it. Now the producer has actually produced. We've emitted this ready product, which means we're going to have to connect our consumer to this ready product and then consume this Q shared pointer my class. All right, so let's jump into our consumer here. And I'm going to, through the magic of copy and paste, bang, Q object, Q debug, Q shared timer, Q time, not timer, Q time, and the my class, this little guy here. And then we're going to just, if we want to save just a smidge of time, we can grab this, jump back over to our consumer. And voila. Now all we have to do is right click, refactor, and bang, there we are. Now our consumer is going to be super, super simple. Not really focused on the producer consumer design pattern at this point. We're just talking signals and slots. So we're going to say this, and let's go bang, and consumer is working. Grab him. Really not doing anything. We're not going to grab like an Academy Award this year or anything like that. We're not curing cancer. We're just doing some arbitrary work. And we're going to say PTR test, and I'm going to say Q time current time to string. So if you're wondering what is this test, it's in our my class, and it's just going to say, hey, this object, this value right here. It's just going to spit it out on qinfo. Like I said, we are not doing anything even remotely constructive. We are really focused on signals and slots. Let's jump in here, and now we're going to connect these two objects, the producer and the consumer. So I'm going to say producer. Ooh, probably help if I actually had some includes, huh? All right, so let's go ahead and include Q object. Let's go ahead and include Q debug. Let's include producer. And let's include the consumer. Notice what we're not including, the my class, even though in our signals and slots we are actually using this. But we don't have to worry about it. We're going to let Qt take care of that for us. So now I'm going to say producer, consumer, and then I'm going to connect these objects. And you have probably done this thousands of times in your career so far. So Q object, connect, and here we're going to say the producer, and we want the producer ready product, and we're going to connect that to the consumer. and we want the ready product. Now I want to just produce this until the end of time, but I'm going to now connect our producer, or actually our core application, the about to quit signal, to our, you guessed it, producer stop slot. I like saying that, stop slot. All right, so really what we're doing here is we're saying when our Q-Core application is about to quit, it's going to emit a signal. We're going to read that signal in under the producer stop, which of course will stop our timer. That way we don't have this class running in the background indefinitely. And then I'm just going to say producer start. Kind of a fire and forget solution, right? Save and run, and let's see what happens. All right, so our producer is producing, and every 3 seconds we should get something. Yep, constructed, consumer's doing, there's a time, finished, item produced, destroyed, blah, blah, blah. And it's just going to keep doing this over and over and over again until we close this program. So what is so special about that? We kind of take this little guy, the QObject Connect, for granted. When we build, what actually happens here? Let me bring up the right directory. There we go. All of this is generated for us. We have our consumer, our main, our makefile, and we have all of these, but what's this? Mock, that's right. I'm sure you've heard of mock before. Mock stands for Meta Object Compiler. So what really happens in the background here is that Qt takes all this code. Let me actually rebuild this. There we go. All right, jump up here. So what actually happens is bang, go to clean, and then mock. We're going to remove these files, and then we're going to call make. And in this process, in through here, mock actually happens. And what mock, or the Meta Object Compiler, does is it jumps in, analyzes your code, and says, what do we need to do? And at that point, these files are created, these C++ files. Let's see if I can pull one out here. There we go. And this is auto-generated for us. We don't have to do any of this. In fact, this file will be deleted. So it says meta object code from Breeding C++, and it tells us where we got it from, created by, and let me actually kind of resize this. And this is some pretty cool code if you start looking at this stuff. So it's using the Qt core, and then it's going to figure out the meta type. And this is why meta typing is so important. To be a Qt QObject, you have to have some sort of meta type, even if your meta type is just QObject, so we can work with signals and slots. And then it calls a bunch of stuff, and it actually says, and you can see right here, consumer, and then you see exactly what it's doing under the hood here. Now this stuff is, well, the source of madness. If you just try to just look at this and figure out what it's doing, you're like, what? But here's the actual static meta call right here. This is what happens with the signals and slots under the hood. So do not try to really dive into this code, and don't try to go in here and start modifying it. Don't look at this and go, oh, you know what, I really feel like doing something and changing that. No. Don't do that because it's automatically generated. And let's see what happens if we clean this. Let's go back to our, and notice how all of those files are now gone. That's why you don't go in there and try to modify them. I'm going to be brutally honest with you. There are temptations to go in and try to change the meta object compilation process. Do not, and I repeat, do not try that. You will not end well. So, in short, when we build, the real secret sauce to Qt here is it takes all of like the QObject Connect and then this little macro here, the QObject, and it does all this stuff in the background for us, so we don't even have to think about it. Just wanted to touch on that as a refresher in case you kind of slept through that day in class. But when we talk about signals and slots, really what we're talking about is mock code that gets generated for us that's called in the background that we don't even need to think about. Okay, This video, we are going to talk about disconnecting. Have you ever had a disconnect, like you and your significant other just have not been talking? That's exactly what we're going to do. So, no, we're not going to get into a fight with our significant other. As funny as that would be, we're not going to do that. Instead, we're going to do the opposite of connecting. We're going to disconnect to Q objects. And we're going to show a reason why you would want to do that. This is something that we often take for granted. We don't really do a whole lot. Honestly, I rarely find a need to actually disconnect two objects. All right, so let's look at an example of why we would want to disconnect two objects. So we're going to create a class. I'm going to make an alarm clock here. Probably shouldn't call it an alarm clock. It's more of just a general alarm. And we're going to QDebug. And then we're going to QTime. And we're going to also add QTimer. And then I want to gonna add that, and then I want to you know what, I'm gonna stop fighting the IDE. I need to get into the habit of actually trusting things. QTime mlimit, and let's go ahead and right click, add the getters and setters in there. Let the IDE do the magic for us. Add that in there. Now we want a public slot. Somebody asked me, does it really matter like what order? Do I need to do signals before slots or slots before signals? No, it 100% does not matter. As long as what you need is where it is, you don't really need it moved around anywhere specific. There's some people that like, yeah, slots should always go up above signals, like this should be up here. It really 100% does not matter. All right, so we're going to take this, put this where it actually belongs, and we're not really going to emit any signals. We have a private QTime, and we've got a getter and setter. Very, very simple code here. Let's go ahead and add that in. I'm going to grab something off the screen here and bang, just gonna save. And then let's go ahead and we're going to say alarm set for and mlimit. Now timeout, this is where we actually do some sort of interesting stuff here, and I'm going to say QTimer, and I want to get the sender out of this. So what we're going to do, you guessed it, is we're going to hook into a timer here, but this slot, this timeout slot, is going to be called outside of this class, so hence signals and slots. So I want to know who called me. So I'm going to say QObjectCast. QTimer, and I want that to be a pointer. Now, if we do not have a timer, something went horribly wrong, and we need to just eject right out of this. It's like in the early 1980s shows, they'd hit the ejector button and boom, you're out. That's exactly what we're doing right there. Now we're going to say if QTime current time is greater or equal to our limit, then we want to do some things and then sound the alarm. We're not actually going to sound the alarm, but it sounded really, get it? We're not going to sound the alarm, but it sounded really good. Anyways, so we're going to sound the alarm and we're going to say QInfo, and this is where we would do something if we were interfacing with a bit of hardware or if we wanted to play like an MP3 or something like that. For our purposes, we're just going to display in the console, as boring as that is. now this is why we would want to disconnect. There's a timer out there somewhere, this guy, and he's going to keep emitting regardless of what we tell him to do. And we no longer want this to be called. So the only way we can really do that is either to ignore it, but it'll still get called, or you guessed it, disconnect. So we're going to disconnect the timer. And we want the timeout, which is what's calling us. And we want to disconnect this, and we're going to disconnect the alarm timeout, our slot that we're currently in here. So the general premise here is somewhere, which we haven't done yet, there is a timer. That timer is going to be connected to our timeout. And then every time that timer fires, it's going to do this. We're going to cast to see we actually have a timer. If we don't, we hit the eject button. If we do, we're going to say, is the current time greater than or equal to the limit we were given? If it is, sound the alarm, and then we no longer want to hear from that timer ever again. So this is the beauty of signals and slots, is that you can connect them and disconnect them and treat them in various fashions here. Let's give this a build, make sure we didn't goof anything up. So far, so good. Put some includes in here. QTime, QTimer, QDebug, QObject, QList, and alarm H. In case you're wondering how I magically get these includes, I have them in notes off the screen just to save a few minutes of typing here. All right, so what we're going to do next, we're going to make an alarm function that's going to actually just generate an alarm for us. And we're going to talk about creational patterns later on, but right now we're just doing this. So we're going to make this alarm. We're going to say alarm and we want new alarm. Seems a little weird, isn't it? Now we are going to alarm, set that limit, and we're going to say Q time, current time, and we want to add a few seconds here, and we're just going to add however many seconds they told us. In case this little bit here is giving you an eye twitch, it probably should. We could actually do this differently. Like that. I'm going to leave it this way so I don't get a lot of hate mail. All right, and then we're going to say QObject connect, and now we want to connect our timer. We want that timeout signal, and we're going to connect that to our alarm. Timeout. There we go. So that's where our connection is really happening, and then of course we are just going to return that alarm. Now, danger. What have we done? What heinous crime have we just committed? You guessed it. We have created a dangling pointer, impossibly. I should say possibly. So we've created a pointer, and we're just going to shoot that pointer out into the beyond, hoping somebody out there takes care of it. Well, yeah, I don't like that, so we're going to actually take care of that pointer because pointers scare me. They keep me up at night. So I'm going to make our timer. And we're going to set the interval for 1 second. So every second this timer is going to fire off. I'm going to say timer start. Now, and I want some screen real estate here so we can see what in the heck we are doing. Now we're going to say Q scoped pointer. You knew that was coming. Alarm. And then we want to say alarm 1. And let's go ahead and make an alarm. And I want this to be 5 seconds from now. And I'm going to give it our timer. So really what this is going to do is going to make a QScope pointer alarm 1 from this guy, and it's just going to connect the signals and slots from the timer and our alarm object. Pretty self-explanatory here. And I want to set object name alarm 1. Just want to see exactly what's going on under the hood. And I can actually just make that very, very easy. Let's grab this. I always miss that first letter. All right, so we're going to have 3 alarms. We're going to have alarm 2 here. And let's set this for 10 seconds. And then we want to say alarm 2. And then we want alarm 3. Very easily could have done this in a for loop. Set that for 15 seconds. Alarm 3 is going to say alarm 3 is the name. And we're done. So what's going to happen here is we are going to get rid of this blank space, or that'll annoy me. We're going to build this, make sure we've got no little gremlins. All right, nothing's going to come back and haunt us, hopefully. We're going to take a timer, set it to 1 second, start it off, and then we're going to make some alarms. And we're just going to connect the signals and slots from the alarm to the timer. Where is it? There it is, timer. And because this timer's happily firing off every second, we need to, you guessed it, disconnect whenever we don't want to hear from that anymore, because it's going to keep emitting that signal over and over again. This is actually, if you play video games, this is actually a pretty common pattern. Instead of each object having a timer, because timers are expensive, they'll have one timer, and that timer controls a lot of different objects. So I think they call it the global timer or something like that. Let's run it and see. Ta-da! It's just going to run for 15 seconds here. It looks pretty noisy because we have these timeout, 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 and then alarm. So let's clean this up a little bit here. This guy is what's making all the noise, so let's just comment him out, run that again, and see what this looks like. So we have our 3 alarms set, and then we should see alarm 1 and then alarm 2. So there's alarm 1 just went off, and then 5 seconds later alarm 2 should go off. Then alarm 3 should go off in 3, 2, 1, boom. There it goes. I got a little nervous there when I said boom and nothing happened, but you get the point here. That timer is still firing away in the background, but we are no longer listening to it because we've disconnected from it. So that's a really good example of why you would want to disconnect if you have something like a global timer and you only want to listen to that object for a certain amount of time or until a certain event happens. I want to talk about automatically connecting signals and slots. And yes, Qt does do this to a certain degree. For example, if you're in widgets or QML, it may do it if you follow a certain naming convention, but it's a little bit error prone, and then you spend half the day trying to figure out why it's not calling it. And if you really dive through their documentation, you're really not going to see any example of them automatically connecting signals and slots. They just assume that you're going to call connect and disconnect. And if you're like me, doing this over and over again becomes highly repetitious, boring, and well, it just sucks. Even if you look in their advanced signal slot usage, you can use Lambda functions, but they don't really talk about auto connections. Oh. All right, so we are going to make our own auto connection class here. So I've got some code here. I've got a client. This literally does almost nothing. Really, it just has a testing function, and it's going to emit a signal called test, which is going to have a QString representation of a number. Really not, Nobel Prize winning code here. And then a server, which, if we look at the header, is just as simple. It's just got a bunch of slots which mimic the client signals: connected, disconnected, ready, read, test, connected, disconnected, ready, read, test. So it's almost verbatim the same thing. And we're just got a producer consumer style pattern here where the client's going to emit some signals, the server is going to consume those signals and do something. And we've got a Q object pointer to the sender. I could have literally just said sender. Yeah, it doesn't matter. I did it my way. Let's put it that way. So I did it my way. I just connected, disconnected, ready, read, and they're literally the same thing over and over again. We're just going to say internal from, test from, ready, read from. So I'm just letting us know. I literally could have written this like Q info sender, or actually this Q func info and sender, or something like that. You get the point. I could have done something like that if I really, really wanted to. But just in case somebody's downloaded this and they don't understand any of that, I want to make sure it's painfully obvious what's going on. So what we're going to do now is we're going to take the signals from the client and connect them to the server. But I'm not going to write the connect over and over and over again. So what we're going to do here is we're going to say main, and let's just do this. We've got those in there, and I'm going to make a client, make a server, and then I want to test them. That's right. Whoops. You can call, or you can emit a signal while you're outside of a Q object. That's incredibly cool that you can do that. Not something I would highly recommend, but you can do it. And we're going to emit ready read. Client testing. There is a method to my madness. Just bear with me here. And then we're going to say client disconnected. So what we're doing is we're showing that, hey, the client, if you really look at him, we're only emitting one thing from inside the client, this test. However, outside of the client, we're going to emit connected, ready, read, and disconnected. This testing is what emits test. I should probably put emit test. Now what we're going to do is we're going to write a header only class, which I don't often do, and we're going to take that class and make it connect the two objects together. And as long as those two objects are Q objects and follow our naming convention, everything should just work. So I'm going to write AutoConnect, and this is probably one that I'm going to have a lot of spelling errors, so please be very patient. All right, so we are going to connect signals and slots of two objects. For example, signal test to slot test, meaning they have to be named exactly the same. As long as they line up, it should connect them. We're going to include Q object, Q debug, Q list, Q byte array, Q child event, Q meta object, and Q meta method. Remember, under the hood, signals and slots really are just mock generated code. And because they're mock generated, Qt gives us all of these wonderful little classes we can work with, like the meta object and the meta method, and we can figure out, you guessed it, through reflection, what each class has. Wow, that's incredibly cool. So I'm going to say class, AutoConnect, bang. Now I want public, and this is where I will probably start screwing up really badly. Void, and I'm going to say connect. See, I lied to you. I said I wasn't going to type the word connect. So now we have a static function here, and I'm going to say I want a Q object sender and a Q object. My keyboard's sticking. I hate that. Receiver. And did I misspell receiver? I did. Shame on me. They need to integrate spell check because I just sometimes do not spell well. I don't know why. So we're going to say if not, sender, return. If not, receiver, return. I want to make sure we have pointers to both objects here. this is where we have to actually do something. We want to get the signals. So we're going to say QList, and I want a Q byte array, sender signals. Told you I was going to goof up, equals, and we're going to have to do something here. And what we're going to have to do is create a function that scans them. So let's pause right there and let's go down and let's create our private static QList. I said QList, do my bidding, computer. And I want a Q byte array. Let's call this, I'm always horrible at picking names. Let's call it scan type. Why not? Scan type. And I want a Q object objecty. Boy, I really misspelled that. All right, Q object, and I want the Q meta method, and I want a method type. And that may seem like voodoo magic at the moment, and I apologize, but really what we're doing is say, scan an object and look for a specific meta type. Now remember, when we talk about meta, we're talking about data. So this is the data created by the mock, the signals and slots, and we're going to just return a list of them. All right, now we can go back up here and make this make some sort of logical sense here. So now we're going to say, want to scan type, and we're going to scan the sender. I really should pick different names for those, but and we want the Q meta, and I want the Q meta method, and we're going to go with signal. So we want the sender signals, and then we can just do the magic of copy and paste, grab this, and then we can say we want the receiver slots. And we're going to scan type receiver, and we want slots. So we're just going to generate two lists. So now let's actually fill in this scan type here. And let's go ahead and say QList, and I want the Q byte array because that's what we're going to be making. And I'm going to say list, and if not object, I probably should do this first. And I'm going to do this, just return this blank list here. All right, now, if we've gotten this far, we have an object. We need to say const Q meta object, and we want a pointer called mo equal object meta object. So we're just going to get the meta object. So we're saying Q object give us your data of data, meaning your meta object. It sounds really confusing, but basically what happens in the background, when you build your Q object, the mock will go in and put a lot of data in there in the form of a Q object. Oh boy, they have some weird naming conventions, but I do absolutely love this. This is just so cool that we can do this. We're going to say I equal mo dot method offset and we want I is less than mo dot method count. And in case you're wondering what the method offset and method count is, count's pretty self-explanatory. You're going to have a number of things, but the offset is, well, for lack of better terms, this. So if we're scanning for signals, we will have like a public, a few things, and then signals, and that's the offset in the position of where this is. There's more to it, and I'm probably explaining that very badly, but think of it in those terms and it makes perfect sense. All right, so now that we've gotten this far, we've got an object, we've got a meta object. I should probably test to see that we have a meta object. We're just going to return our blank list if we can't get that meta object. And then we're going to say QMetaMethod, because signals and slots are really just methods. And we want MO method and then whatever the count is. Then we're going to say if method, not method type. Now, interesting enough, we're working with the QMeta objects, and we could have tried to use like a for each, but ironically, the meta objects don't really have metadata, so it's kind of hard to do things like for each. You can do it, but it's kind of tricky and error prone, and I wouldn't really advise it. I've had all sorts of issues in the past. Anyways, now we're going to just say if it matches that type, we're going to list append, and we're going to say method signature, which just is a qbyte array, which is basically just going to be a string representation here. Wow, is that confusing, but it's really cool that we can do that. So basically we're taking an object, saying give it a certain type, signal or slot, get the information about the object, scan through the methods at the offset, and then look for something that matches that type, whether it's a signal or slot, whatever we're scanning for, and if so, append it to the list. Now that we've gotten to this point, we can just say return our list, and life should go on. All right, so we're actually returning a copy. We could do a pointer, but I really don't feel like it. Now we're going to go up here, and this is where the interesting bit really happens. We're going to say for each, and in our for each, I'm going to say qbyte array signature, and I want in the sender signals, and this is what we're going to do. We're just going to line up the signals with the slots. So we're going to say if receiver slots contains the signature we're hunting for, that qbyte array. So if they both have it, and this is what I meant by you must have a test and a test, or a signal and a slot that have the same signature. This is what we're talking about here. If those two line up, then we want to automatically connect them. And then I'm just going to say qinfo auto connecting, and let's go ahead and pump this out signature. That way we know what we did. Now I'm going to say QObject, and this is where I need to stop and kind of explain some things. We can't really do this connect the way we normally would. Why? Oh, this part is a little frustrating. It'll take you a bit to figure out, but I'm going to Control-C and paste some notes in here. If you dig through the source code of Qt, and I really, really hope they don't take this out, or they add some way of auto-connecting signals and slots for us. If you dig through the source code, you'll see the old school signals and slots macro. So the new way is like, connect, and then you give it an object, and then you say, the function pointer, the, what is it, the class, da-da-da. That's the new way. The old way, you would actually say signal and notice how that macro pops up. So really what we're doing is we're kind of backboning off these signals and slot macros. If you look at them, they're really defined as define slot A equals 1 and pound A. And this pound A is just going to print whatever you put in it. So it's slot for 1, signal for 2. Very, very important you remember that part. So now we're going to take our connection, and we're going to say, hey, sender, and I want to say 2 plus the signature. And then I want to say receiver, and I want to say 1 plus the signature. You're probably looking at this going, what in the heck are you doing? Okay, so let's slow down and explain this. So there's multiple ways to connect a signal slot, and let's just walk through them. So we're going to say QObject connect, and let's say sender, it needs a pointer, right? And then we're going to say Q object, whoops, and we're going to say signal, and then the receiver, and then the Q object slot, whatever that may be. And this is going to give us a horrible list of errors because it doesn't actually exist. But that's the new way of doing it, right? So the old way, and I remember doing this for years and years and years, connect, and you can still do this, sender, signal, and then something like test, and then receiver, and then the slot macro. And that was the old school way of doing things, and it still actually works. But you notice how it doesn't have any error checking. If we try to run this, it will try to compile that even though it doesn't exist. That's why they switched to this newer method of connecting. So really all we're doing is we're looking at the signal and slot macros, and we're saying, okay, so signals puts a 2 in front of whatever it is. So we're just going to put a 2 and then the signature. And a slot does a 1 and then the signature. And the meta object compiler is going to handle all the rest for us. We don't have to do anything else. That is incredibly cool. Let's give this a good build, make sure I didn't type anything wrong. Jump into our main and let's test this out here. So now I'm going to include our auto connect. And then I'm going to say, probably should have done that lowercase. I'm surprised it's not complaining at me. I'm going to say auto connect, and I want to connect the client to the server. Now, as long as the signals and slots line up, and when I say line up, remember like the signature, test to test, so we're talking connected, disconnected, ready, read, test, connected, disconnected, ready, read, test. As long as those line up, it should try to auto connect them. Remember, our client is only emitting the test. We are emitting them here, the connected and ready read. Anyways, enough talking. Let's see this thing in action. Boom. So auto connecting, connected, disconnected, ready read, and then, all right, so we got test, 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 bunch of stuff. So we connected, ready read, disconnected. So it is working as expected here. That is incredibly cool. So if we wanted to, let's play around with this even further here. Let's take our client and let's get that out of there just to show this is working as advertised. So server connected from client, server ready read from client, server disconnected from client. Everything works as expected. Wow, that is incredibly cool that we can do this. Now, my hope, my dream, is that we don't have to do this kind of stuff. As cool as this is, my hope is that Qt 6, when it comes out, will have some sort of like auto connect class. So you can just say, hey, do this. And this may not be the way you want it. Like you may want your naming convention to be test with like on test or something like that. And that's perfectly fine. You can just simply change it down here in your scan type and make sure that that works. You get your scan types back. And then you come in here and it says where it contains, and that's where you would check, and you just convert it to a string and do whatever you wanted to do with it. Simple, easy to use, does what it says it does, and we won't ever have to type a signal and slot connect again. Oh my God, that's brilliant. However, for this course, I will not use this. Why? Because I don't want somebody going, I don't understand auto connect. I didn't watch that one video. Can you explain the scan type and what we're doing? So this is the one and only time I'll be doing this. The rest of this course will be using this convention right here, unless I'm forced into using, we'll use this convention here, the newer way, unless I'm forced into using the older way. But in the real world, outside of this course, absolutely feel free to auto connect your signals and slots. As long as you can connect them together and it does what you want it to do, there's absolutely no problem doing that. This video, we're going to talk about the sender function, and we often just kind of take this for granted. So let's crack open a console application. We're going to go Qt5 design patterns. And this is 5.4, and this is one of those videos I'm probably going to make a boatload of mistakes because there's a lot of typing involved. All right, so what is the sender function? Well, it is the object that emits the signal. So we're actually working with this in the slot, and you've probably, I hope, you have seen this and used it and understand it. But I wanted to give a good, solid, real-world example of why you would even need this, because a lot of people just kind of ignore it. So we're going to add networking, which we just did, and then we're going to go in and add a new class, and let's call this server. It's a queue object. And once it generates the code for us, we're going to go in here and we're just going to copy and paste some includes, queue object, queue TCP server, and queue TCP socket. So we are going to make a simple TCP server. And when I say simple, this is basically going to be a mini chat server. So we're going to flip back here, right click, and I'm just kind of going through really quickly a lot of just the basic stuff that you should probably already know for this course. It's assumed that you've already made a few TCP servers in your time. All right, so what we're going to do next is we're going to look at two different ways of doing this, two popular methods. The first one is we're going to hold a list of clients, or I should say a list of pointers to clients, and the second one is working with the sender function. So because we're going to be holding pointers, RAII, we need to actually make sure we get rid of things when we don't need them. All right, so make our deconstructor, maybe if I could type. Don't you ever hate it, like when your keyboard's just a little bit off center and it screws you all up and you're like struggling to just do basic things? All right, so got our constructor, our deconstructor, and then I'm going to go ahead and go here, say private. I'm going to make a queue list of queue TCP. Wow, I am way off. Sockets, and these are going to be pointers, of course, called mClients. And then I want a function, which is going to just, you guessed it, send to all the clients. We just want a string value of some kind. And then I want another function, maybe. There we go. QString, and I want to get the client name. So the premise here being, when people join our chat server, we're going to ask them for a name. We're going to store that in the object name of the socket, and that name is who they shall ever for be known as. And let's go ahead and implement these. All right, so far, not rocket science. Incoming connection, a list of clients, and two functions. We're going to also add in some slots. So I'm going to say and I'm going to copy this straight out of Qt's documentation for the Qt TCP socket. The socket's going to emit a connected, a ready read, and a disconnected. So why are these public? Doesn't need to be. They could be protected, they could be private. We're really the only ones that are going to be using it. So let's go ahead, flip there. I'm just allowing it in case I wanted to use this class later on and say, hey, want to use something outside. And when I say outside, I mean outside of this class. So, all right, so we are going to close the server down when the server is destroyed. And let's go ahead and go with just want to check something super quick here. Nope, not in there. All right, good. Wanted to make sure I wasn't doing something incredibly dumb, which I probably am. Usually I do something dumb, but all right, so we're going to say we have a list of sockets, and when the server's destroyed, we want to close the server down. And at what point we want to say, okay, close that down, and I'm going to do a for each. And I'm going to say QTCP socket object in our clients. And then I'm going to say socket close. And so we don't have any dangling pointers out there. I'm going to say Q delete all. And we're just going to let Qt take care of the memory management for us. So any sockets that are sitting there, we're just going to say bang, close them all, delete them all, clear them out, and then close the server down. And from here, our life actually gets a little bit interesting. So we're going to say incoming connection. This is where the socket comes in. And I'm going to say Q TCP socket. And somebody out there is probably saying, why aren't you using automatic memory management? Why aren't you using like a shared pointer or something like that? I just simply don't want to be brutally honest. There's a billion different ways of doing this, and I'm just showing one specific way. The way that I'm showing is, I think, a little less cumbersome by using the Q delete all, but yes, you can absolutely use Q shared pointers or the standard library automatic pointers. All right, so we're going to make the socket. We're going to append that socket into our list on the incoming connection. And then, because I absolutely detest making connection codes, we're going to connect the socket connected to our connected and ready read to our ready read, disconnected to our disconnected. And if we were not concerned with students skipping videos, we would have used the auto connection class that I made in a previous video that would have automatically connected those signals and slots. So socket, I'm going to set the socket descriptor, which basically tells the operating system, hey, we are now taking ownership of this. And then I'm going to emit the socket connected. Now, why am I doing this? Why am I emitting a socket connected? Because when we accept this incoming connection, the connection's already been made. The operating system's already said, hey, we accept this. Now, it might not have done it completely on the TCP stack, but the socket itself thinks it's already connected, so it won't emit that. Kind of confusing and frustrating when it does that. All right, so the other reason is we have our socket connected to the server connected, and it's going to call this guy right here. It'll never fire off if we don't emit it. Now down here, this is where we actually play around with sender. I'm going to say Q TCP socket, and I'm going to say Q object cast. Oops, not send all, sender. There we go. As funny as that would be, we're not going to send all before we even have the object. And then we're going to say if not socket. Then we're going to actually return out of here. Very, very simple code. You've probably done this before, but what are we really doing here? We're saying, hey, give me the object of the sender and make sure it is castable to a QTCP socket. We're not even saying that this has to come from inside this program. This could be a socket from a different class. It could be a pointer off a different program, which gets into a vastly different conversation where you're just grabbing a memory location and then sending that as an integer, and then the other program makes a pointer and points to that memory location. Not always possible on every operating system, but some of them let you do that. So Q byte array, data, and I'm going to say enter your name. And then we're going to say socket write, and we want to write that data. And I'm not going to do any like socket wait for bytes written or anything like that. I just want to fire it out and forget it. And because it's a pointer, I don't have to worry about it going out of scope or anything like that. Now, you may be sitting here going, no, wait a minute. Hold up. We've got the socket already in our clients list. Why are we getting it out of this? Well, we have to do that either way. We have to know who sent it to us. And then we could, if we wanted to, make sure, like, you know, M clients contains socket, blah, blah, blah. We could do something like that, but honestly, I don't really care. If we have a connected socket, I want to make sure I can talk to it. Ready read, just going to grab this little bit here, make life a little bit easier. And I might just do the same for disconnected. All right. So ready read. We're going to say qbyte array value, and I want the socket read all. And we could do some other checks here, like, is the socket open? Is the socket readable? Things like that. If we were writing vastly more complex code, we would do something there. All right, so now I'm going to say qstring line, and I want to say value trimmed. That way, if they just entered a bunch of nonsense, or if we have a trailing line refeed hard return line feed, it gets rid of that. Now, this is where we're going to do some sort of logic. I want to say if the socket's object name is not set, then they have not really entered their name yet. So there's not a whole lot we can do here. So I'm going to say socket set object name is going to be the line. So this is, we're assuming they've connected. We've already shot off the into your name, and they've responded to that. And now we're going to take whatever they typed in and just set it as the name. Whew, a lot of explaining there. All right, so qstring data equal client name. And we're going to get the client name of that socket, which should be down here. We haven't filled out yet. So let's make a quick detour down here so we know what this is doing. And we're saying if not socket return qstring of unknown. So we don't know who that person is. Otherwise, we're going to return the socket, you guessed it, object name. Really simple, very, very rudimentary code. Yes, in case you're wondering, this clients list, we could, instead of storing sockets, we could store some sort of class that represents the socket or the client state. For example, name, password. I wouldn't store the password, but name, password, nickname, how many minutes they've been connected, that sort of stuff. All right, anyway, so back down here, we are simply going to say data.append, and we're going to say that person, whatever their name is connected. And we're going to let everyone know. Man, I cannot get that today. There we go. Connected. Sometimes it's the simplest things that really screw us up. And then we're going to send all, and I want to say data. And we have not fleshed out send all yet. So let's jump down there so we know what this is doing here. We're going to say the value, and we're going to append that with a hard return line feed. Say qbyte array, and I want to go data value dot to UTF-8. So really all we're doing is just converting that string into a UTF-8 encoded byte array. And then I'm going to just every single socket for each in our clients list. And here's where you would do some sort of make sure it's not in the process of disconnecting or something like that. You're just going to simply say if the socket's not null, we're just going to write that data out. We could do that in one line if we really, really felt like it. So that's what sendall is going to do. It's going to go through our list of connected clients, and if they're in there, it's just going to say if it's not null, shoot out whatever data we gave it, and put a hard return line feed at the end of it. All right, back up here. I know I keep sidetracking, but we're almost done. If the object name was already set, then I want to say get their name, and then I want to data append, and I'm just going to do a little dash there, and then data dot append the line, whatever, not lane, line, whatever they sent us there. And now I want to also send all that data. So the logic here is pretty simple. Somebody connects, it's going to say enter your name. They enter something that forever becomes their name. And then after they type something else, it will get sent to everyone. So it's just a mini chat room basically. All right, so disconnected, we are almost actually done with this server here. Man, we whipped right through that. Disconnected, this is where we want to actually say, all right, mclients remove, and I want to remove one. You could like remove all or whatever you want to do, but I'm just going to remove one because there should only be one. Remove one of those sockets. And then I'm going to say, very simple, I'm just going to copy and paste this because it's super easy. Bank. Now this is where you're kind of going, whoa, wait a minute here. Client, remove one. Doesn't that delete the socket? Nope, it doesn't. It just removes it from the list. So that socket's still out there somewhere. And this is where we have a bit of a memory leak issue. Now, knowing that's a memory leak, what we could do is something like this. Delete later. And that tells Qt, hey, you know you actually created this, delete later, which actually schedules the object for deletion. And what that will do in the background is say, okay, Qt, you have a rough idea, it's not a guarantee, but you have a reference count of where this object's used, and when it's no longer used, go ahead and delete it. I've had problems with delete later in the past, especially with TCP servers, where Qt thinks the socket's no longer in use, and well, guess what? It's still in use and it crashes the whole system. So the only time I'll call delete later is when I am beyond a shadow of a doubt not worried about the socket screwing anything up. The problem here is disconnected could come at a very bad time, meaning we could get this disconnected signal, but there was still data on the pending socket, like something weird happened with the TCP stack and it says disconnected and then you receive data and then bang, your program dies. Now, obviously that's not the way things are supposed to happen and it's rare, but I've actually seen it happen and it really just made me mad when it happened, to be brutally honest with you. I sat there for like an hour trying to figure out what was going on. All right, so we've got a good build here. Let's go ahead and jump over to our main. And we may have some small bugs that we need to go figure out, but I'm fairly confident in this so far. So say include qdebug, and let's go ahead and say include our server. We're going to go ahead and make an instance of our server, and we're going to say if not server.listen, and we're going to listen on Q host address any, and I want to listen on, I'm just going to choose port 3924. Hopefully that's not colliding with any sort of application or known virus or anything like that. So if we can't listen, I want to say Q critical, and I'm going to say server error string. I love the fact that Qt did that error string. I don't have to call any fancy API calls or last error or any nonsense like that. I say, hey, tell me what went wrong. Otherwise, we're going to say the server is now listening. All right, so let's give this thing a whirl. I'm going to give it a good build, make sure we didn't goof anything up. Give it a run. Server is listening. All right, so let's bring up Telnet, and I'm going to actually move this off to the side. This is our server here. Here's our client 1, and I'm going to say Telnet and 127.0.0.1. That's our local loop back. 3924 is the port. Enter your name. My name is Brian. Brian has been connected. Now, so what we're going to do next is we're going to open yet another. Probably because I have the wrong port. Ah, yes. 3924. Silly me. Enter your name. There we go. Let's say this is Tammy. And you notice how over here it says Tammy's connected. So now I'm just going to drag you over here. And so there's Brian, there's Tammy. See if I can kind of scooch these over so we can see them. You know, so it says, Tammy says, hello, I'm Tammy. And then Brian says, hello, Tammy, I am Brian. And it just works. So really what we have here is a very rudimentary server, but we've demonstrated senders along with signals and slots. And I'm going to close this guy, bang, and we can see that Brian has disconnected. Now, what's happening under the background is a whole lot of memory management. And we could do some fancy things like, you know, hook in a about to quit into server close and things like that, but you get the general principles here. What we're super focused on in this video is, again, the sender function, this guy. We often take him for granted, so some key takeaways are the sender is going to give us a pointer to a queue object. It's up to us to make sure through QObjectCast that that object is the data type we're expecting and that we can do something with that. Now, in a real-world application, what I would probably do is, for example, on connected or something like that, I would actually say, you know, like clients. Now that we have a socket, I would say like, if not clients dot contains the socket return. That way, if, you know, the newbie in accounting who became a programmer who thinks he's going to do something super cool tries making a connection through, you know, signals and slots and tries sending his socket from another class altogether into this server, it doesn't blow up the server. The other main takeaway here is memory management is not always crystal clear when you get into Qt. You may have to backbone into things like the very rudimentary QDeleteAll, or if I can find it, socket delete later, or actually QObject delete later. Okay, this video we're going to talk about signals and slots with their connection types. And if you're an expert in this, feel free to skip this video, but there's some people out there that may not have ever really used a connection type, and maybe, you know, you need a little bit of encouragement or you need some foundational knowledge here. So I've got some code written. We've got this my class, and it's a very simple class. I didn't want to waste a lot of time going over it, but it just simply has a constructor of a QObject parent and a name, and then it's got a function along with a signal and a slot. We can actually switch in here. And so we're just setting the name in the constructor. The constructor just says destroyed. And notice how all these say QThread current thread. We want to know what thread these things fired off on. So perform is just going to emit a signal called test. And onTest is actually a slot, and it's going to be the consumer of this test. So we're literally going to make two objects called myClass, and we're going to hook the test from object A to onTest of object B, just so we can play around with these things. Now when we flip into the main, super simple. We have a test function which is going to take a myClass, this guy, that is a source, and a myClass, again this guy, which is the destination, two of the same object, and it's going to connect them using the Qt connection type. And by default, it's going to be the Qt connection auto connection, which is normally the default anyways. And we also have this little thread in here because we're going to move these to two different threads and see what happens. And that's what's going on right here. So first and foremost, we're going to take the source and destination. We're going to connect them using the connection type, and we're going to go over the connection types. And if there is a thread, we're going to take that destination and move it to that thread. And because we're doing the move to, we have to make sure that this destination does not have a parent, or it will give us some sort of error. And then the code is dead simple. I didn't want to waste a lot of time writing code here. So we just have the myClass source, the myClass destination, and their name, source, and destination appropriately. The current thread is being named main thread, and this is the thread that main is running on. So this is our main thread of execution. We're then creating a second thread, and we're calling that separate thread. We're not doing anything fancy, like we're not connecting the A about to quit to the thread close or any thread quit or anything like that. We just want to see how the connection types affect the signals and slots between two objects. Now, if we pull up the documentation, there is the auto connect, direct connect, Qt connect, I should say Qt connection, blocking queued connection, and unique connection. This is fairly interesting, and they've got some pretty decent documentation. So auto connection by default is a direct connection. What? So then why do we even need auto connection? Why shouldn't they just use direct connection? Anyways, really what it says is auto connection, if the receiver lives in the thread that emits a signal, direct connection is used. Otherwise, queued connection is used. Meaning if these are on two separate threads, it's going to go between direct or queued. Now why is that? If we look at direct connection, the slot evokes immediately when the signal's emitted. So it doesn't even wait, it just says, boom, I've done something. But if they're on two separate threads, queued connection is the way to go. And queued connection is going to say, the slot is invoked when the control reaches the event loop of the receiver's thread. So you have two threads, A and B. Thread A says, hey, I'm doing something. And it puts it into literally a queue of, I'm guessing, pointers of signals that have been emitted. And when the receiver's ready, because the receiver lives on thread B, and thread B may be asleep or busy or doing something, but when that thread becomes available and ready, it's going to read all those queued up slots or queued up signals and say, okay, let's go ahead and process all those, and then it calls all the slots. Whew, that's confusing. It's confusing because threading is a nightmare when it comes to cross-thread communications. And the reason why we're making this video is whenever somebody comes to me and says, well, I have an object on thread A and I have an object on thread B and I'm trying to do this and I can't figure out the mutex locker and this and that, I say, why are you doing any of this? Just use signals and slots. It's literally what it's designed for. And they have all these connection types. So let's go ahead and play around with this. So auto, remember, source and destination are on the same thread because we do not have a connection type or a thread yet. It's just going to backbone to the connection type auto, and the thread is going to be null. So both of these are going to be on the same thread. Let's put it that way. Let's run this. Works as expected. All right, close. Direct connection, same thing. Source and destination, same thread, but we're going to use the direct connection. Remember, direct connection is going to fire off immediately. So same thing as auto because they're on the same thread. Queued connection, a little bit interesting here. Source destination on the same thread, but we're using a queued connection. So because it's using the same thread, it's just going to fire off immediately. Ta-da! Works. And this is the simplicity of signals and slots. And this is why I kind of scratch my head when people say, well, why shouldn't I use, a callback or some sort of weird memory construct or do some memory mapped file? Just use a signal and slot. Anyways, blocking queued connection. This is dangerous. Whenever you see the word blocking, always be fearful. Why? Because this will deadlock. And let's flip over to our documentation here. Blocking queued connection, same as queued connection, our buddy here, except that the signaling thread blocks until the slot returns. What does that mean? You have two people, let's say you and Bob, and you and Bob are having a conversation. And you emit a signal and say, Bob, go do something. I'll wait. And that's literally what happens. The signaling thread waits or blocks until the receiver, in this case Bob, goes and does whatever we tell him to do. This is super dangerous because you can actually block your thread, and that's why programs stop responding. The connection, it even says, the connection must not be used if the receiver lives in the signaling thread, or else the application will deadlock. And they do have a little bit of what I call training wheels in here, meaning they try to save you from yourself. Doesn't actually kill our application, but it says queued deadlock connected while activating, so it actually skips right over that. So whenever you see the word block, you got to ask yourself, are you doing this the correct way? And then unique, we can actually use unique on its own. It's really not designed to do that. Basically what unique is for is if you want to make sure that connection is, well, unique. It does what it says it does. It says this flag can be combined with any of the above connection types or using the bitwise or when unique connection is set, QObjectConnect will fail if the connection already exists. Meaning you want to make sure you're not making multiple connections to the same thing. So for example, if I were to just grab this, and I were to go in here and let's say source, destination, and let's grab this unique connection. So we've got the QObject connect and the source, destination, once the IDE catches up with what we're doing. And let's make a bunch of these. There is a method to my madness here. So we've got a bunch of the same object and the same destination, same source, same destination, same signal, same slot, but we're using the Qt unique connection. What happens? Nothing, really, to be brutally honest, because we haven't done anything. So let's go ahead and go emit source, and let's say test. Let's go ahead and emit that bad boy manually. We're just going to force it to go off. And then it says test from. Now you notice how we've got a bunch of these. Scroll back up. We've got a bunch of these, but it only fired off one time. Now let's go ahead and do auto connections here. See what happens. My keyboard has betrayed me. There we go. Again. Why are you like this, keyboard? Notice how it fired off a bunch of times. So that's really what unique connection does. The documentation sounds super scary where it says will fail if the connection already exists. So will fail seems super scary, but really all it does is it makes sure that we don't have that fire off multiple times like we see here with the auto connection. So when in doubt, if you start seeing something's firing off multiple times, just add in the unique and you're good to go. Now comes the interesting bit, threaded. So we're going to do the same tests, auto threaded. So here we have source, destination, our auto connection type with a thread, and this is this separate thread. And let's see how this works. Now notice how everything just works beautifully. This did not used to be the case. With older versions of Qt, you had to actually tell it, don't use a direct connect, use a Qt connection. But if you start running into problems, like if you're firing off your signal and you're using auto connect and the destination's just not get it, switch over to a Qt connection. But here in our test case, everything worked fine. But you can see it's destination test, blah, blah, blah on separate thread. And moving along, direct connection. This is where we're going to have some issues here. So you see how we've got source created on thread, destination created on moving to, and then source emitting signal and destination. Here's our problem. The sender is 0, 0. So we still get the signal, firing off our slot, but that sender is now null. It's 0, 0. So if we were to try to say, hey, cast the sender, blah, 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 it's not going to work. And that's because we're doing a direct connection cross-thread. That will get super frustrating if you try to take non-threaded code and move it to threaded code. And that is why they tell you in the documentation pretty much just rely on auto connect. But if you want to tread where no one wants to go, all these other things exist. And these things exist because auto connect didn't used to really act that way. Qt connection works exactly the way we expect it to because auto automatically detects whether it's single or multi-threaded. So when you see direct, think single. When you see Qt, think multi in terms of threading. And voila, works exactly like we think it would. Blocking. Remember, when we see block, this can be a bit dangerous. Even with two different threads, it can be a little dangerous, but for our test, it worked beautifully. But what really happens here under the hood is a bit scary. So the current or the main thread will go in here and it will call this, and then it will immediately block until that is emitted. When I say that's emitted, we're actually talking about the code in here. So if I were to say something like qthread current thread ms sleep and something like this, or even longer, just to make it painful, and flip back, let's test this and see what it does. So 1, 2, 3, 4, bang. There it goes. So that's what I mean by blocking. You can do some really bad things if you're not expecting this to block and you have blocking in there. Really, really bad things could happen very quickly. And last but not least, unique connection works as expected, even cross-thread. So the real main takeaways from this is you probably fell asleep during that day of class when we were talking about the connection types. Usually I'll trust auto connection, but if I start seeing issues pop up in a multi-threaded app, I will switch them all queued connection without even missing a beat. I will just stop trusting auto and switch over to queued because something underneath the hood with queued is not detecting that it's on a different thread. Although I will admit the last 5+ years, things have been pretty rock solid in that respect. Blocking queued connection I almost never use just because it's so dangerous and it does block your sending thread. But if you want a cheap, easy way of saying do something and wait for the other thread to do it, that's how you would. I don't like doing it though. And unique connection keeps multiple connections from occurring, which, like, if you, let's say, every time you say hi to Bob, he's going to save up $1. And you say hi to Bob 20 times, and at the end of the day, Bob has $20, and you only meant to pay him one time. That's what unique connection does. It makes sure that you don't create that connection every single time. So in a nutshell, those are the connection types. Main takeaway here is pretty much trust auto connection, but if you run into issues, switch over to queued connection. Rarely use blocking queued connection because of the dangerous consequences. And while I personally don't really find a need for unique connection, it does have its special use cases. This video, we're going to talk about signals and slots to and from an application to a library. So we're going to say new, and we're going to say other projects, subdirs, and we're just going to make a blank subdirectory project. So we're going to say Qt5 design patterns, and this is 5.6. And finish and add subproject. Now we're going to go to a console application. Let's call this my app, and I'm just whipping through this really fast. It's just assumed you already know this. And once that figures that out, then I'm going to go File, New. Actually, I'm going to right-click and go New Subproject, just faster that way. I'm going to go to Library, and then I'm going to go to C++ Library. And let's call this mylib. Next. Next, and this is going to be a shared library. This is where people get a little bit confused. We don't want a Qt plugin because, well, we're not plugging into the Qt system. We don't want a static link library because we're not doing a static build. We want a shared library, and this would do, well, exactly what you think it would. It would make a library, an SO, a DLL, what's it called, a dynlib on Mac, those kind of things. So this is going to be called mylib. There's the header, there's the source, next, and finish. Okay, let's go ahead and go into our projects file. There's a little bit of surgery we need to do here. We want to make sure that our library is built before the application. So I'm going to say config plus equals ordered. And then we're just going to grab him through the magic of copy and paste here and move him up. And what that really is going to do here is it's going to say build this one first, then build this one, not the other way around. So that's what ordered really does. All right, so let's go ahead and give a good build, and that's going to build both of those out. And let's jump into mylib here. Now, it's assumed that you've already made libraries before, but just in case you haven't, we've got these two header files, the mylib globals. This is what makes the definitions, or does the defines, to export or import our actual class. And you can see how it says class mylib export. If you're wondering where it's getting that from, it's right here, mylib export. And it's going to do a qdecl export or a qdecl import depending on how it's being used. So if you're exporting or importing, and it gets into these weird, if you're not an expert in C++, it gets into imports and exports and what symbols you're going to export. I'm going to say this very badly. If you're wondering what a symbol is, every function, every member variable, everything you can imagine has a symbol inside of it. I've said that very poorly, but it tells in a very easy manner where those symbols are. So we need to tell it, take anything that's flagged with the mylib export and export those symbols so they are usable in other applications. I should actually make a class on that because it's way more in depth than what I just said. But all right, so we're going to take some includes, QObject, QTimer, QTime, and I'm going to say class. Notice this is not a QObject, so we're going to convert this into a QObject. And in doing so, we of course need to do some brain surgery here. So I'm going to say QObject parent not done yet. Out of line definition. What did I goof up here? I'm sure I did something wrong. Ah, yes, we haven't finished this yet. So I'm going to say explicit mylib QObject pointer parent. And this is going to default to a null pointer. Not done yet. We need to upgrade this using the macro to a QObject. Still not done. Ta-da! Now we are, for lack of better terms, a QObject. Let's give this a build just to make sure. If we're super paranoid, we can right-click and rebuild just the lib, make sure everything builds the way we expect it to. But now this is actually a QObject, and it can have signals and slots and things of that nature. So let's go ahead and say looks like I screwed something up. I looked down at the keyboard and I was looking at my fingers while I was typing, and boy, should not have done that. All right. So we've got some signals there, and let's go ahead and say public slots. Again, looking at my fingers while I was typing gets me every time. That's one of the little challenges about doing these live unedited videos is I make a lot of typing mistakes. For example, sloats. There's no such thing as a sloats. And if there is a sloats, I don't think I'd want sloat in my code. All right, so void timeout. And then private, we're going to make a QTimer. All right, now we just need to implement our slots, not sloats, slots. And there we go. Let's give this a build, make sure I didn't miss anything. All right, good. Go into here and let's say we want to set our interval to 1 second. We're going to go ahead and go connect our timer. And really all we're doing is we're just building a class out that's going to, on, you guessed it, a timed interval, emit some sort of signals, and then we're going to consume those in our application. So we're just connecting up our timer. When we start, we're going to say mtimer start, and then we're going to emit started. And then you guessed it, we're going to do the exact opposite and stop. We're going to say mtimer stop. And let's go ahead and go to emit stopped. Timeout, we're just going to emit triggered. We could have done this, again, a billion different ways. I'm going to say current time, toString. Really nothing fantastic about this. All right, so let's go ahead and give this a good rebuild. We've got some delicious little libraries that were just created out here, so we're good to go. Now on Windows and things like that, you're going to see it'll be a different naming convention, but as long as you have a good build here, you're good to go. Say, ta-da! Windows is DLL, Linux and it's SO, and Mac, I think you can do either SOs or dylib or something like that. I'm not an expert in Mac, but that's the beautiful part, is I don't need to be, because Qt does a lot of that for us. So what we're going to do next is we're going to go into our My App here, and I'm going to actually collapse that so we're not even thinking about this little library here. I'm going to add a new class, and I'm going to call this client. Because we're working with signals and slots, we need a Q object to work with. So this client is going to consume the signals and slots. So I'm going to, before I go any further, I'm going to right-click our application. I'm going to go Add Library, and I'm going to add an internal library, meaning a library internal to this project. You can add an external, a system library, a system package, but I'm going to do an internal, and of course the library I just built. I want to be able to import this for Linux, Mac, Windows as a library, not a framework. And I'm just going to basically leave everything as default unless you really want to play around with this stuff. This tells us what it's going to do to the project file of our application. And go ahead and hit save. The really important bit, assuming you've done this before, but just in case you skipped that day of class, this is the project file for our application. It added this little bit in here which tells it, hey, this is how you find the library, because all this code we want to be able to work with. And then we have an include path and a dependency path, and it says the working directory, going to go up and then go over to this mylib folder. Close that. And what I like to do is just give it just a second, because sometimes it pops up and says building or thinking. And then I go in here and I build the application. And if you have any sort of, symbol not found or linker not found or instruction not determined or any sort of weird error message, 99% of the time it has to do with a path issue of looking for where that lib is. Whew. All right, enough of that. Let's go in here and let's go client. I'm going to add in Qdebug, and I'm going to import the mylib, and I want the mylib global, and I want the mylib h. So this does really two things here. It actually goes in and we're just reusing these header files. We could have added them into our project directly, but it's just reusing them. We need the globals because it has this little guy here, and our H file has our class header. So we can just close that out. As long as you don't have any red squigglies and it can find it, you're good to go. But usually I like to give it a full build just in case. You notice I'm building a lot. I get a little bit paranoid here. So we're going to say void start, void stop. Now I want a signal. I'm going to say void limit. Some public slots. Really don't need to be public. And I'm going to just copy and paste these from that header file. Started, stopped, triggered should look very familiar from our lib because it's the exact same thing. And from private, I'm going to say mylib, call this underscore mylib, and then int mcount. So really, what are we doing here? Simply making a client, which is also a queue object. It has some public functions along with some slots, and it has a signal, and we have a mylib from our library, along with this little count guy. All right, so let's go ahead and flesh in our slots. And just in case you missed it, we're going to do the old copy and paste here. Signals and slots work as expected. Ooh, what is this? Undeclared identifier. Mylib. There we go. For some reason it doesn't like that. Spelling, that's what it is. My notes are different. My notes have betrayed me. Easy fix. Case sensitivity. All right, so we're just connecting the signals and slots. So we're going to connect our mylib object started to our client started, and then stop to stop, triggered to triggered. And then we're going to say this limit to the lib stop. So once we hit a limit, we're going to actually tell that library to stop. Whew, pretty simple code. Just a lot of talking, and I absolutely hate making connection code, this stuff. That's why I prefer to just copy and paste it. And then I'm going to say mylib, and we're going to go ahead and start. And calling signal, I'm not going to put that in there. I was going to explain something totally different, but not going to go there. And then for stopped, I'm just going to go bang, bang. Stop. And then I want to say we're missing some stuff here. That's why I have this backwards here. Mistakes have been made. I'm very sorry. All right, let me fix this super quick. I thought that looked really, really funny for a minute. That's why it screwed me all up. So, all right, let's fix this. This should make a little more sense now. Gosh, how embarrassing. All right, so start is going to start, stop is going to stop, and then on our slots, we're going to do something different. So when we are started, we're going to say QInfo. See how easy it is to get all screwed up. And the old copy and paste here. Then for triggered, I'm just going to say mcount ++ if mcount. Did I miss something? I did. So if count is greater than or equal to 5, then I want to say, hey, we have hit our limit. So I'm going to say emit limit, and then just return out of here. Otherwise, we just want to go in here and say QInfo, what are we currently on? And let's go ahead and print that value out. And we could put the count in here too if we really wanted to. That way we see exactly what happened. So I'll go ahead and give this a rebuild just in case. Whenever I work with libs, I get super paranoid because I've had Qt kind of betray me before. I shouldn't say Qt. 99% of the time it's my own dumb fault, but I blame Qt. There we go. So what are we talking about? Signals and slots inside of a library. Works great across libs. Sometimes people become a bit confused about libs. You saw me get a little bit confused, but that was more just me being dumb. Want to make sure we have a mylib and a myapp and do that config ordered. And then we're going to add that library like we did. So what we do from here is very simple. We're just going to test this out. going to make our client. I'm going to say client and client start. Very simple, very easy. Give it a build, run it. Started, and there we go. So we've got signals and slots operating across a library. This is insanely cool. So what this means is you can take your Q objects and put them in a lib, and then from there, just use them however you need them. The only real catch, I don't even really want to call it a catch, it's more of a mandatory requirement, is anything you want to use, you're going to have to export. Otherwise, you just will not see it in your calling application. But again, we're talking about signals and slots inside of libraries. And as you can see, they work just beautifully. They work exactly the way you would expect them to work, as long as, unlike me, you spell it right. But there's really no extra magic you have to do. As long as you're talking from one Q object to another Q object, everything just works beautifully.